Hello students, this is your friend Sumit and today we are going to start topic 3 of the series, that is kinematics. Kinematics is one of the interesting, important and at the same time the fundamental topics from where we start learning physics. Kinematics is very interesting. We feel it, how the particle is moving, how to find its velocity, acceleration, the range, the height and all those things, the relative velocities, the graphs, so many important things are asked from this particular chapter. Okay, the graphs questions are asked, the relative velocity questions are asked, the projectile questions are asked and many more things. Now, if I talk about the weightage of this particular chapter, it has a decent weightage. We can expect one question from this particular chapter, but you may say, so the weightage is not that great, but it has its application in other chapters. If you talk about electric charges and fields, it has its application. If you talk about motion of a charged particle, it has its application in that. If you talk about, let us take laws of motion, work energy, power, thermodynamics, kinematics has its application everywhere. Okay, so make sure you make your fundamentals very strong. So in this video I'm going to cover each single key concept you need to master to get 99 percentile in JEE mains, and I'll make you practice the questions. After watching this video, make sure you practice the questions. We have a very good collection of questions and the class notes for you, and you'll get all these things on our app. The link of that is in the description box. As you know, the PW app is one of the biggest platform where so many students prepare, and even students gets AIR 3 by using that. Okay, so make sure you don't miss that, because after seeing me solving the questions, you need to practice yourself also. Okay, so let us begin the discussion. So we are going to cover first the fundamentals of vectors. We will not go into much details of vector here. We'll just try to understand the fundamentals that are required for this particular chapter, what is vector, and addition and subtraction of vector, unit vector, taking the component of a vector. These things I'm going to talk about, and then quickly we'll start motion in a straight line and motion in a plane, and at the end the circular motion. Okay, so let us begin with the first topic, that is vectors. So basically, you know that vector has magnitude, vector has a direction, and it follows vector algebra. So any quantity which has magnitude, which has direction, and which follow vector algebra, we say that that particular quantity is a vector. Okay, so how we represent vector? So let us take, if we show a vector like this, okay, so the length of this vector represent the magnitude, and the direction of this vector represent the direction. Now, if I ask you, let us take this vector as having some magnitude 5 units. If you have to draw another vector of 10 units, what you will do in the same direction? So you'll increase the length to twice. Now, this is one direction. We may change the direction. So if we say that vector, let us take two vectors are there. So if I ask you when the two vectors are equal, so the two vectors will be equal if both are having the same magnitudes as well as the same direction. It's not that just the magnitude is same, we will say the two vectors are equal. No, they should have the same magnitude as well as the same direction. Now, direction is there. So how we define direction? You may say we have some standard directions like x along x-axis, along y-axis. So we can take the take a vector and define its terms of I cap and j cap. I cap is unit vector along x-axis, j cap is unit vector along y-axis. Or let us take, if there is some another direction you want to define, you may write the unit vector of that particular direction with the magnitude, and that's how it will become like the direction of that particular vector. How? Let us take, this is our vector, and the angle of the vector is theta, like this. Okay, I'm taking this as my x-axis and this is as my y-axis. So if I take the components of this vector, I take to make this right angle triangle, this becomes my, if this magnitude is, let us take r, so how much length is this? This is r cos theta. in this right angle triangle. Okay, this is my right angle triangle. Similarly, on the other side, this will become r sine theta. So this vector is having r cos theta magnitude along x-axis, r sine theta magnitude along y-axis. So when I represent this vector in I cap and j cap form, so I'll say r cos theta I cap plus r sine theta j cap. This becomes my r vector. I cap and j cap are the unit vectors. Their magnitude is 1, but they are showing the direction. Okay, so I'll say this is my unit vector along x-axis. Okay, let me write it. This is my unit vector along x-axis. And this is my unit vector along y-axis. And let us take a vector is in the 3D space, so there will be some component along z-axis also. So I'll say plus that much component k cap. Okay, for z-axis we use k cap. Okay, now let us take a vector is there. I'm saying a vector A is there. So can we write a unit vector along the direction of A? Now A is having some magnitude and its direction. Okay, so what will be the unit vector along in the direction of A? Just divide with the magnitude of A. This will become my A cap. Okay, so vector divided by its magnitude. Now here if you talk about the magnitude of this, the magnitude is 1, there is only direction, so this becomes the unit means 1. Okay, magnitude is 1, so this becomes the unit vector along vector A. Okay, so I'll say this is my unit vector in direction of A. Okay, so when we write magnitude, like here I wrote magnitude, just I wrote A, so sometimes we write like this. This becomes my magnitude. I may write like this or I may write like just A. So that represents the magnitude of that particular vector. Now, let us take some vector is there in terms of I cap and j cap. First of all, I'm talking in 2D only. Okay, so let us take my vector is there, A vector. This is 3 I cap plus 4 j cap. If I ask you what is the magnitude of this particular vector, how will you find it? This is 3, this is 4. Okay, the magnitude means this length, that is the hypotenuse. So you'll say just the magnitude here is root of hypotenuse when I'm finding the base square plus the perpendicular square. So it will become 3 I cap square, 3 square means not I cap, plus 4 square like this. So that is 5. And if there is some k cap term also there, okay, then you need to include that also. Okay, so if I write, let us take my vector, some vector that is A, this is ax I cap plus ay j cap plus az k cap. If I ask you what is the magnitude of A, so it will be root of ax square plus ay square plus az square. Now let us talk about addition of two vectors and subtraction of two vectors. Okay, before that, one more thing. As I discussed initially, let us take this is my vector A. So what will be, let us take 2A. If I ask you 2A, you will say the direction is the same, the magnitude become twice. So this becomes my 2A. If I ask you what is my minus A, Now when I am multiplying with minus, it means the vector becomes in the opposite direction. Negative means the direction of the vector becomes opposite. Okay, magnitude is never negative. Magnitude is like it's the magnitude. Okay, that is having some value. Okay, no sense of negative there. If a negative is there, it means the direction becomes the opposite. This is minus a, so my minus a vector will be this. Got it? Now talking about addition of vector. I'm not going to go in much details of vector as I discussed. Okay, I'll just tell you fundamentals because I quickly want to start kinematics. Okay, so addition. Let us take we have two vectors. This is vector A and another vector. This is vector B. And here the angle between the two vectors is, let us take theta. Now how we say angle between the two vectors? So you have to take the angle between the tails or the angle between the heads. So this is the tail of the vector, this is the head of the vector, and you have to take the smaller one. So this here I'll say theta is the angle between, or I can shift them and find the angle between the two heads. Okay, that also I can say that angle will also be theta only. Okay, now let us find the resultant of these two. How to find? What we can do is, now you try to understand this. This is my B, this is my A. I want to find the resultant of these two vector, and these two vector are given at an angle theta. Let me first properly write it. This is my A, this is my B. Okay, I'm using triangular law of vector addition first, then I'll come to parallelogram also. Okay, this is the angle theta. I'll say this is my B cos theta length, this is my B sin theta length. Okay, and the resultant of these two will be this. This is what triangular law of vector addition says. Okay, and this becomes the hypotenuse of this bigger right angle triangle. What is this hypotenuse now? Let us take this resultant is C. So I'll say this C magnitude, if I talk about, is base square. What is base? A plus B cos theta. Total length will become A plus B cos theta plus the height square. Okay, so from here I got my magnitude as root of A square plus this B square cos square theta and then B square sin square theta, that will become B square because cos square theta plus sin square theta is 1. So A square plus B square plus 2AB cos theta. And you can find the resultant, the angle of the resultant vector, as if I write tan alpha from here, that is B sin theta divided by A plus B cos theta. Okay, this is triangular law of vector addition. And parallelogram law of vector addition is, here I can show you. This becomes a parallelogram and my resultant vector will be this. Okay, and same way you can find this magnitude will come out to be the same, and the angle alpha, this will also come out to be the same. This is one of the way how we find the magnitude and the direction. Another thing, if I talk about, another way if I talk about is, you can just take the components of the two vectors and add or subtract them in terms of their components. Like let us take here the same. This is my A, this is my B, this is theta. I'm taking horizontal direction as I cap, vertical direction as j cap. Okay, x-axis and y-axis. So if I talk about A, this is along x-axis, so I'll write A as, let me use different color. I'll write A as the magnitude, that is A, and the direction I cap. If I write B as, I need to take the components along x-axis, that will become B cos theta if you draw the right angle triangle. Okay, A may be bigger also. Okay, and along y-axis it will become B sin theta. So if I write B here, that will become B cos theta I cap plus B sin theta j cap. And now I need to take the resultant C, that is A plus B. You can add I cap with I cap, it will become A plus B cos theta I cap plus B sin theta j cap. And if you have to write the magnitude, you can just write the magnitude root of the component along I cap square plus the component along j cap square, like this. Okay, and if you have to find the angle, you can say tan theta or tan alpha, angle of the resultant C, tan alpha, that will be my y component divided by its x component. This is how we write tan theta or tan alpha, the resultant of the two. Okay, now this is another way. Or what you can do is, let us take some multiple vectors are there. Okay, multiple vectors are there, then what you can take, you can take the components, and there itself you can cancel few of the things, like some components may cancel along x-axis, some may cancel about along y-axis, and just write the final components of along x-axis, final components along y-axis, and then take the resultant like this. So this is what you can do. Now subtraction of two vectors, there is no difference between addition concept and subtraction concept. Only thing is, when you subtract, if I talk about subtraction, so when you say that my C vector is A vector minus B vector, so I will say this is A vector plus minus of B vector. What is minus of B vector? Just the opposite. Okay, add them to, that will become the subtraction. Okay, and then there is dot product, cross product, all these things we are not going as of now, because we don't need that in this particular chapter. Okay, when we will come to work, power, energy, then I'll talk about dot product, and in rotation I'll talk about cross product. Now let us begin the topic. Basically, this was just some fundamental things that we needed. Now we are starting our kinematics topic. First, let us discuss about position, distance and displacement. These things are fundamental, and I am very sure that most of you understand these things, but let us quickly revise them. Okay, let us quickly revise them. What I'll do parallelly for 1D and 2D. First of all, if I write for 1D, 1D means the particle is moving along one of the direction. Let us take x-axis. Okay, and let us take this is my x-axis. Now let us take this is my origin 0, x is equals to 0 here. The particle is moving along x-axis. At some instant you want to write its position. How will you say? Let us take the particle is somewhat here, and this is x naught. So you'll say the position is x naught, isn't it? Position, you'll say that is x naught. And same thing if I write for 2D, let me take x-axis and y-axis. and the particle is moving in this plane, and let us take the particle is somewhat here at some instant, and the position vector, this becomes my position vector. Let us take this as my r. The coordinates here are, let us take x naught comma y naught. So when I'll denote here the position, I'll write that this is x naught I cap plus y naught j cap. Simple. This is in 2D. This because there are two coordinates x and y. So I need to tell how much length along x axis, how much length along y axis. In 1D there was only one coordinate, so I just wrote that coordinate. Okay. Here we need not even write I cap or that because it's understood. It's moving in one direction, so one of the coordinate will be there. Next is the distance and displacement. So what is distance? Distance, you know, the path length, total path length, and the displacement means the change in the position, how much the position changed. Let us take that example. Let us take in 1D first, my particle moved from this x naught, went like this and came back till here. Okay, it went like this and then it came back, and now you are asked what is distance. So you will write here the distance is my total path length, this plus this, so this will become my path length. Now you find how much was what was the coordinate at this particular point, take the difference, you'll get this length plus how much the coordinate of this point, and then find this length and add the two, so that become my total path length. And if I talk about the displacement, displacement is just change in the position. This is the initial position, and let us take my final position is this, okay, x final. So you just need to subtract these two. You'll say the final position minus the initial position. This is my displacement. You find the coordinates, you subtract that. Same thing if I talk for 2D. Let us take my particle is moving in some way like this, and it moved from this point till here. And you are asked what is the distance. So you will say distance means I have to find the path length. So I need to find, let me check, change the color. So I need to find the total length, the length, this total length. Okay, so this becomes my distance. Okay, this becomes my distance. Now if I ask you how much is the displacement, you will say this is the initial position vector, this is my final position vector. Let us take this as our final and this is our initial. And if I ask you what is the displacement, you will say the displacement is just the change in position. Final minus initial. This minus this, how much is that vector? Okay, if you write this final minus the initial, that will become this. This is my displacement here. You can see this from a triangular law of vector addition. Okay, this vector plus this vector is my this final vector. I need final minus initial, so you'll get that vector. So this is how we define position in 2D and 1D. And let us take the particle is moving in free space, 3D. Okay, so there one additional direction, z axis will also come. So there when you define the position, so you'll write xi cap plus yj cap and plus whatever is the z coordinate, zk cap, like this you'll write. Okay, same for the displacement also. You when you'll take the difference, you'll write both the vectors in terms of I cap, j cap, k cap, and then you'll write them accordingly. Getting it? Let us come to some questions. and this question was asked in JEE Mains 2024. Let us read what it's mentioned here. A cyclist start from point P, this is point P, of a uniform circular of a circular ground of radius 2 kilometer. Okay, this is circular ground, radius is 2 kilometer, that is given. Travels along circumference to point S. It comes from here till S. Okay, the displacement of the cyclist is, as I mentioned, displacement is just the change in position. Now here he just need the magnitude. Now you may say, sir, displacement is vector. It's not mentioned in vector form anywhere. Okay, it means he is just asking the magnitude of that vector. Okay, so this is initial position, this is my final position. Yeah, this is my final position, this is my initial position. I need the displacement, I just need the magnitude of the displacement. So I'll take this path length, this length, okay, from here to here. How much is that? This is r, this is r, so this is r root 2 simply. And what is r? 2 kilometer. So r root 2 if I write, so that is 2 root 2 kilometer. Okay, which option is correct? 2 root 2 means that is root 8, so root 8 kilometer. Got it? Now let us talk about average speed and velocity. So first of all, let us have some conceptual clarity about these things. Many times what happens, like some question of average speed is there or average velocity is there, and then a few things are mentioned, half of the length, half of the distance it covered with this velocity, half of the time like it covers with this velocity. So many times we are confused which formula we have to use, which formula we need to use, whether we should use 2v1 v2 upon v1 plus v2 or v1 plus v2 by 2, or there will be some another thing here. Sometimes we are confused. Why? Because we don't have conceptual clarity. So let us develop conceptual clarity and accordingly we will solve some questions. First of all, average speed. Average speed is my total distance it covered divided by the total duration. Okay, so I'll say this is my distance divided by the time interval. Just simple, nothing complicated to learn. Next, average velocity. This is my displacement divided by time interval. Average speed questions are asked in mains. Okay, many times they are asked, and these questions are just simple but sometimes confusing for few of the students. Coming to such questions, as shown in the figure, a particle is moving with constant speed, that is pi meter per second. Considering its motion from A to B, the magnitude of average velocity. We need to find the magnitude only. Magnitude of average velocity, so I'll say that is magnitude of displacement divided by time interval. That's all. Okay. So V average, I'll say that is my displacement here divided by the time interval. How much is the displacement? It is moving from A to B. So how much is the displacement? Displacement is this path, this length, okay, this length between the two positions, final and initial position. This becomes my displacement. Now how to find that? This is R, this is R, this angle is 120 degree. So what I'll do, making this perpendicular, this becomes 60, this becomes 30. So this becomes R cos 30 and this is also R cos 30. So this total become 2R cos 30. 2R cos 30. Okay. So this is my total displacement, and what is the time it takes to go from A to B, that also we need to find. Now here it is mentioned the speed is pi meter per second. If I know the distance, I can write the time as distance divided by speed. Okay, so delta t is the distance divided by the speed. What is the distance? Angle is 120 degree. 120 I can write as 2 pi r by 3 because sorry, 2 pi by 3, pi by 3 is 60. So 2 pi by 3 is the angle and the radius is r. So this arc length will become 2 pi by 3 into r because arc length is theta into r. So it will become 2 pi by 3 into r divided by the speed, that is pi. So this is 2r by 3. I got this as 2r by 3. Now let us write it. What is the displacement? 2r cos 30 divided by the time 2r by 3. Anyways, this 2r is getting cancelled and this will become 3 root 3 by 2. That is 1.5 root 3. Now this question was certainly not confusing and was very straightforward. You might have done just by saying it. Now coming to the question, another question. A car travels a distance of x with speed v1 and then same distance x with speed v2 in the same direction. The average speed of the car is, okay. Now first it covers a distance x and here the speed was v1. Then here it's saying that same distance x with speed v2 and then we need to find the average speed. So when I say average speed, so this is my distance divided by the time interval. What is the total distance? X plus x, so 2x divided by, what is the total duration? So this, whatever is the duration in this, let us take this time duration is t1 and duration is in this is t2, so it will become t1 plus t2. What is t1? So t1 will be distance x divided by v1. What is t2? Distance x divided by v2. It will become like this. So what it is now here, 2v1 v2 divided by v1 plus v2. Okay, that is option D. Sometime he may ask like half of the duration it goes with v1, half of the duration it goes with v2, and then you need to find, okay, and then it will become like v1 plus v2 by 2. So let us take if half of the duration is there. So when I'll say distance, so that time I'll write distance as v1 into t1. Let us take duration is t and t. So v1 into t plus the second total distance, that will become v2 into t. So this becomes my total distance divided by total interval, that becomes 2t, and then it comes v1 plus v2 by 2. So if the time is half, it will become v1 plus v2 by 2, and if the distance is half and half, I'll say equal, then it will become 2v1 v2 divided by v1 plus v2. But don't remember this formula, don't get confused, just understand the concept that it is, if it is asking average velocity, displacement by time interval, if it is asking average speed, distance by time interval. Understand this concept, nothing else is required. Don't memorize anything. Now see this question. A particle is moving in a straight line. It covers half the distance with 6 meters per second and the other half is covered in two equal intervals with speed 9 and 15. Now let us take total distance was d. Now half of this till here, d by 2, it is covering with speed 6 meters per second. This is my d by 2. And next half in two equal intervals. Let us take the total interval here, I'll say, let us take here interval is t. So it is covering in two equal intervals. So for t by 2, it is going with velocity 9 meters per second. Let me write it. a bit more clearly. So for total interval is t. So for t by 2, it is going with 9 meter per second. Next to t by 2, it is going with 15 meter per second. Just use the concept. Don't memorize anything. Don't memorize anything. Just use the concept. So I'll say I need to find average speed. So I'll write V average to be the distance divided by the time interval. This formula only I know. I don't know anything. Okay. Now just write what is the total distance d divided by what is the total interval. So here what time it took for 6 meter per second plus then 9 meter per second and you can say 15 meter per second. Now for 6 meter per second how much time it will take? That will be distance divided by speed. So d by 2 is the distance and the speed is 6 meter per second. So this is the interval here plus what is this interval? I wrote that as t. I took this interval as t. Okay, so I wrote that as t. Now this distance is d by 2. This distance is d by 2, that I know. So I'll say this distance d by 2 is equal to the distance it covered with 9 meter per second. How much is that? 9 into t by 2 plus the distance it covered with 15 meter per second, that is 15 into t by 2 okay, and from there I got my t, that is d divided by 9 plus 15, that is 24. D divided by 24. So I'll write it here. So this will become d divided by d by 12 plus d by 24, and what it will become from here? It will become 24 divided by 3, that is 8 meter per second. Option D. Okay. So therefore I'm saying that you should not remember any formula, because if you remember, like you may remember, many of the students remember and solve accordingly, but it's not required here. Therefore I'm saying just understand the core concepts, use that core concept, you'll reach the final answer perfectly. Another question, two trains A and B of length L and 4L are traveling into a tunnel of length L in parallel tracks from opposite directions with velocity 108 and 72 respectively. If train A takes 35 seconds less time than train B to cross the tunnel, the length of the tunnel L is. Okay, let us take, this is the tunnel. If a train is coming, okay, like this, and length of the train is, let us take L. So how much distance this train need to travel to cover this tunnel? It's just starting, the engine is starting entering the tunnel, okay, till here the engine reaches. Okay, let us take from here to here the engine reaches. How much distance it covered? L, that is equal to the length of the tunnel. It covered L. Now but still, has the train covered the tunnel? No. Crossed the tunnel? No, because engine is reaching here, but the rest of the train is there inside. Okay, now this, how much this train need to cover to exit the tunnel? That is the length of the train. Okay, so it need to cover the distance, that is L, plus the length of the train. So that distance it need to cover to cross the tunnel. So for train A, if I write, and one more thing here, the duration less, that is given in seconds, velocities are given in kilometer per hour, so we need to convert that, and the answer is in meter. So I'll convert these velocities. How we convert from kilometer per hour to a meter per second? You know that we multiply with 5 by 18. Okay, kilometer we convert to meters and hour we convert to seconds, so that fraction becomes 5 by 18. So if I find this velocity, so that is 108, that is 108 into 5 by 18. So 18 into how much? 6. So this becomes 30 meter per second. This is my V1. And what is V2? That is 72 kilometer per hour. So 72 into 5 by 18. So this is 18 into 4. So this is 20 meter per second. Getting it? Now if I write the time it takes for train T1, how much is the total length? Length of A is L, tunnel length is capital L. So L plus L divided by the speed 30. What is T2? The length of the train is 4L, length of the tunnel is same capital L. So L plus 4L divided by the speed. How much is that? 20. And here it is mentioned train A takes 35 less. This T1 is 35 less. It means T2 minus T1 is 35. Now we need to solve it. So this will become L plus 4L divided by 20 minus L plus L divided by 30, and this is given as 35. One more thing that is given to us, capital L is 60 times of small l. So this will become 64L and this will become 61L. Okay, and this thing, if I write 64L by 20 minus 61L by 30, and this is my 35. Sometimes calculations are there, but we need to solve that properly. Okay, so let me write here itself what it will become. I'm taking 60 as the LCM. Okay, 60. So this will become 3 into 64 minus this is 61 into 2, and what it is, this is my 35, this much L. Perfect. Yeah, what it is, 64 into 3, that will become 2, 6 into 3, 18, 19, so 192. Okay, minus how much is that? This is 122, so 122. So the difference is 70. So this difference is 70. So L 70 by 60 is 35. This is 2. From there L I got as 30. Small l is 30. Perfect. Yeah. Small l is 30 and capital L is 60 times of small l. So capital L is 60 times of 30 and this becomes 1800. Option C. Some calculation was there, but the question was not that difficult. Okay, now let us talk about average velocity, average acceleration. As we discussed, average velocity is change in position divided by the time interval. What is change in position? Change in position was that is the displacement. Okay, that is displacement, that is my change in position divided by the time interval. Same way, if I say average acceleration, that is change in velocity. Okay, that is change in velocity divided by the time interval. So I'll say average acceleration, uh, this is my change in velocity divided by the time interval, or I can write it like this: final velocity minus initial velocity divided by the final time minus the initial time. Any of the way you can write, and that becomes my average acceleration. Now, instantaneous velocity and speed. What does instantaneous means? Instantaneous means at that particular instant. At that particular instant. We say average velocity is displacement, the change in position divided by the time interval, the change in the time, I'll say. That is change in position divided by change in time. But when I talk about instantaneous, instantaneous means the change becomes very, very small. Okay, so it will become the rate of change of position with respect to time. Rate of change of position. Okay, now I'm writing this separately for 1D and 2D. First of all, let me write that definition. So this will become rate of change of position with respect to time. And this becomes my instantaneous velocity. So when we are writing V, it means that is instantaneous velocity only. If we write V average, that means that is the average velocity. Now speed means the magnitude at that particular instant, the magnitude of the instantaneous velocity, that will become my speed. Speed is the magnitude of the instantaneous velocity at that particular instant, that becomes the instantaneous speed at that particular instant. So if separately I write for 1D and 2D, if I write for 1D, I was writing my position as x, so I'll say that velocity is dx by dt. Okay, and if I write for uh, if I write for 2D, so velocity is rate of change of position. There is my position vector, so dr by dt. And if you write position vector as x naught I cap, y naught j cap plus z naught k cap, like in 2D you can take only x and y. So if you write as x naught I cap plus y naught j cap, so this will become dx by dt I cap plus dy by dt j cap. So what is this dx by dt? So I'll say this dx by dt is my velocity along x-axis and dy by dt is velocity along y-axis. Now if z is also there, you can write dz by dt k cap. That will become the velocity along z-axis. So here I can write my velocity, okay, vector as my vx I cap, vy j cap. Okay, so this becomes my vx, this becomes my vy separately. And if there is z also, I'll say that is my vz. Okay, so basically we got that velocity is rate of change of position. If we need to find the speed, take the magnitude of this. If you need to find the speed here also, take the magnitude of the velocity there. That's all. Okay, coming to the questions, what it is mentioned, the distance traveled by an object in time t is given by this, the instantaneous speed. Okay, so instantaneous speed means rate of change of distance also, that way also you can say the same thing. So distance is given like this, so I'll say my instantaneous speed is ds by dt. So differentiate it, we learned differentiation, so you know that how to do this. This 2.5 is a constant, taking that out, 2t if you differentiate, this will become t square, if you differentiate it will become 2t, so this is 5t. And he is asking at t is equals to 5, so the answer will become 5 into 5, 25. Option D. Getting it? Some more questions. The velocity of a particle is given. Now we need to find position. Okay. Now it's just opposite. Position was given. If you need to find velocity, differentiate position. Now if the velocity is given, you need to find the position, then what you need to do? Integrate it. Okay, so if I'm saying that v is equals to dx by dt, rate of change of position, so what x will become? So dx will become v dt. You integrate it. Okay, so my here delta x will come. Okay, so initial minus final, and he need to find the displacement only. So let us take initial was x1, final was x2. Okay, and time goes from t1 to t2. So what it is? X2 minus x1, this becomes my displacement. Okay, or I can write this as delta x. This is integration of v dt from t1 to t2. This is what you need to do. Now v is given to us, and uh, also its position at x is equals to 0 is given, that is at t is equals to 0 is given, that is x is equals to 0, and the displacement after t is equals to 1. Okay, means till that particular instant. So we will integrate it as displacement only I need to find delta x. So delta x will become integration of v dt from t1 to t2. V is this. So integration of v naught plus gt plus ft square dt from 0 to 1. First integrate, then put the limits. So if I integrate v naught, this is a constant, integration will become v naught t plus gt, integration will become gt square by 2, g is constant. Similarly here, ft cube by 3, putting limits from 0 to 1, and if you put t as 1 first, minus put t as 0, so what you will get? You will get v naught plus g by 2 plus f by 3. This becomes my delta x, v naught plus g by 2 plus f by 3. B option. Okay. Now you understood, like if you know velocity is rate of change of position, and from there if you integrate like this, so when you integrate the position, it becomes from x1 to x2. Okay, it's not that integration of dx will you just write as x, that the final position. No, it will give you the change in position. Okay, that is your displacement. Got it? Sometimes students are confused whether we got displacement from there or whether we got position from there. Another question, the position of an ant moving in YZ plane is given like this. Okay, the magnitude and direction of velocity of the ant at t is equals to 1. As we discussed, this is in 3D. Okay, basically it's YZ actually. Here, this is 2D. Now if you want to find the velocity, so what I'll do, dr by dt, rate of change of position. What is my position? Write it here. So d by dt of this is 2t square j cap plus 5 k cap. Like this. Now differentiate separately these two things. J cap is just direction. Okay, don't say like how we need to differentiate that. That's a unit vector, that direction. Variable is t square. So when you will differentiate, it will become 2 is constant that will come out, and t square differentiation will become 2t, this much j cap, plus 5 is a constant, that differentiation is 0, 0 k cap. This becomes my velocity. Okay, and what I am getting from here, that is 40 k cap. And we need to find at t is equals to 1. So at t is equals to 1, this is at t is equals to 1. So what it will become, we'll put t is equals to 1 here. 4, I did some mistake. This was j cap. This should be j cap there. Okay. This was 4t j cap. So this is 4 j cap. And j cap we know that is along y axis. So I'll say 4 meter per second in y direction. And these type of questions are asked. You see in January attempt of 2024, this question was asked. Although this question is very simple, I'm writing it everything to show you. Otherwise, if I see this expression, I'll directly say this is differentiation is 4t, so t is equals to 1, so that will become 4 j cap, directly 4 meter per second. You need not solve these type of questions, writing everything on. I'm just showing you how to write. Now let us talk about instantaneous acceleration. As we discussed, instantaneous velocity was rate of change of position. So instantaneous acceleration is rate of change of velocity. So when I say instantaneous acceleration, that is my A, this is rate of change of velocity. If you specifically talk about 1D and 2D here. So if I write for 1D, I'll say my acceleration A as dx by dt, dv by dt, sorry, rate of change of velocity, dv by dt. Because I know here my velocity is only along one direction, so I'll just write dv by dt. And if I talk about 2D, so I'll say my acceleration is dv by dt. Now velocity may be vx I cap plus v by j cap, and if it is 3D, so it will become v z k cap also. So you can differentiate that separately. So acceleration will become dvx by dt I cap, sorry, this was I cap, plus dvy by dt j cap. Now this is my ax and this is my ay. Okay, so ax means acceleration along x-axis. Along x-axis. Ay is acceleration along y-axis. If there is az also, that will become acceleration along z-axis. Okay. Coming to the question part, let us read it. A particle is moving in straight line. The variation of position x as function of time is given as this. The velocity of the body when acceleration becomes 0 is. So we need to find expression for acceleration first, make that equal to 0, get your time. Now you need to find the velocity at that particular time. So find the expression for velocity, put that time there, you'll get the velocity. Let us see the steps. So x is t cube minus 6t square plus 20t plus 15. This is my x. Now if I write velocity, differentiate each term, what it will become, 3t square minus 6 into 2, 12t, plus differentiation 20t is 20, differentiation of 15, that is constant, is 0. This becomes my velocity expression. From here again differentiate to find acceleration. Now differentiate this expression, 3t square, t square differentiation is 2t, so 6t, minus 12t differentiation is 12. Now here is saying when acceleration becomes 0, put acceleration as 0. What is your time from here? 2 seconds. It means you need to find velocity at 2 seconds. Put 2 seconds here in this expression. So velocity will become 3 into 2 square minus 12 into 2 plus 20. Okay. So 3 into 2 square, what is that? 4 into 3, 12, minus this is 24 plus 20. So 20 minus 12 is 8 meter per second. Let us quickly check our calculations. I hope everything is perfect. Yes, we got t is equals to 2. Expression was perfect here. Then putting t is equal to 2 there, 12 minus 24 plus 20, that becomes 8. Yes, this is correct. So we got B as the correct answer here. Okay, so first differentiate, got velocity, again differentiate, got acceleration. He was saying acceleration is 0. I put acceleration 0, got time is equals to 2 seconds. He was asking velocity at that particular instant, put that instant in velocity, got my velocity. Now uniform motion. Uniform motion means the velocity is not changing. Uniform motion means simply velocity is constant. Velocity is constant means both the magnitude as well as the direction. Okay, both the magnitude as well as the direction, not only the magnitude. Let us take if a particle is moving in a circle. Let us take example, is moving in a circle with constant speed 2 meter per second. If I ask you, is that uniform motion? No, that is not uniform motion. Why so? The direction is continuously changing. The velocity is not constant at that particular instant, at any particular instant. Okay, so I'll say here the velocity must be constant, both the magnitude and direction. It means the particle just moves in a straight line with constant speed. That we say uniform motion. Particle will move in straight line. It will move in straight line with constant speed. If that is the condition, motion is uniform. Uniformly accelerated motion. Uniformly accelerated motion means our acceleration is not changing. Acceleration is constant. That is the meaning of uniformly accelerated motion. And you know these formulas. V is equal to u plus at, ut plus half at square. This is our S displacement. V square minus u square is equal to 2x. And the distance traveled in nth second. If you want to remember, you may remember fourth one. And like at least 3 you remember. You may not remember this fourth one exactly, because you can find it. This s nth means it is the displacement in nth second. Okay, the displacement is in nth second. If you want to find that, you can find in let us take here till n and then subtract that with till n minus 1. So you will get only in nth particular second. Nth second means if I said let us say third second. So what it is from t is equals to 2 to t is equals to 3. T is equals to 0 to 1 is my first second, 1 to 2 second, 2 to 3 is my third. Okay, so accordingly you can subtract that and you'll get for nth second. These three equations, you know, if you want to find how we can find these expressions, you can use integration. Like you know that acceleration is dv by dt. Okay, if a is constant, dv is a, that is outside integration dt. V goes from initial velocity to final velocity. V minus u is equals to at. Simple. Time goes from 0 to t. Okay, so v is equals to u plus at. You got this. Okay, and then let us take you need to find the displacement thing, okay, in terms of acceleration. So you can again write v as dx by dt. So dx by dt, this is my v, this is u plus at. Initial velocity is constant, acceleration is anyway constant. If you integrate it again, so my displacement, the integration of dx from x1 to x2, so that is my displacement, so that will become ut plus half at square. And if you like use these equations, okay, to substitute t from one of the equation to another, you'll get v square minus u square is equals to 2s. Just quick revision. Also, one more thing, when we were talking about instantaneous acceleration here, we wrote a is equals to dv by dt. We can write this in terms of x also. Let us take here for 1D if I write a is equals to dv by dt, and if I multiply and divide here with dx, so what it will be dx. So what it will become? I can write it as dx. I'll take on this side, so I can write it as dx by dt into dv by dx. So this is the expression of acceleration in terms of position, in terms of x, you can say in 1D. And if you want to write in 2D or in 3D for general, so it will become v dv by dr there. Instead of dx, it will become dr there. Okay, simple. Where we were? Yes. So we got these three equations. Quickly we derived also. Now coming to some questions. Now questions here are simple on this equation, because in 10th class also, or maybe in 9th class also, you might have practiced these type of questions. Two things are given, one thing you need to find. Let us take time is given, acceleration is given, initial velocity is given, you need to find final velocity. You can use this expression. Or you have to find displacement, okay, and time is given, acceleration is given, initial velocity is given. You can use this. or let us take initial final velocity is given, you need to find displacement, you can use the third, and if something else, another combination is there, you can use these equations to simplify that simply. So see what is given, what you need to find, accordingly use proper equation. Coming to the question, a bullet is fired into a fixed target, loses 1/3 of its velocity after traveling 4 centimeter. So let us take bullet is traveling, loses 1/3. I am saying that initial velocity was v, and then it become loses 1/3 means final becomes, final remaining is v minus v by 3. So 2v by 3 is remaining. And here the displacement that is given is 4 centimeter. Now, further it penetrates d into 10 to the power minus 3 meter before coming to rest. It means now further means 2v by 3 to 0, and here we need to find how much is the distance simply. Okay. Now when it went from v to 2v by 3, it covered distance s. When it is going from 2v by 3 to 0, how much is the distance it will cover? Here we are relating the speeds and the displacement or the distance. So I'll use the formula v square minus u square is equals to 2s for each of the conditions. This is my first condition, this is my second condition. So in the first condition, if I use final velocity is 2v by 3, so 2v by 3 v square minus initial velocity u, okay, what is this? This is v, is equals to 2 into acceleration into the distance 4 centimeter. You may say, sir, why you are not writing that to meters? I'm just writing the unit also here, considering that. Okay, 4 centimeter. Next, it is going from 2v by 3 to 0. So what is final? Final is 0. So 0 square minus initial. What is initial? 2v by 3. So 2v by 3 square is equal to 2a into, let us take here the distance is d. These two equations are here. We got. Let us divide these two equations. So simply divide these two equations, both sides. So when you will divide here, a will get cancelled, v square also will get cancelled, and what it will become? 4 by 9 minus 1. 2 by 3 square is 4 by 9. Yeah, 4 by 9 minus 1 is minus 5 by 9 divided by 1 minus 4 by 9. So minus 4 by 9. So minus sign is getting cancelled, 9 is getting cancelled, and this is equal to what? This 2 will also get cancelled. So this is 4 centimeter by d. Okay, so d is 4 into 4 is 16 by 5 centimeter, and d is given as the distance. Sorry, here I considered that distance only d. So that distance is mentioned in terms of 10 to the power minus 3 meters. Centimeter is 10 to the power minus 2 meters. So it will become 160 by 5 into 10 to the power minus 3 meters. So what is this? This is 32 into 10 to the power minus 3 meters. So the final distance is this, and that is written as d into 10 to the power minus 3. So d becomes 32. That is option C. I think in this question there was a mistake, and this question was given as bonus. Okay, so I changed the options accordingly. This question was given as bonus by NTA. I think so, as I remember. Okay, got it. Another question on this these particular formulas. A car is moving at speed 150 km per hour. After applying brakes, it moves 27 meter further before it stops. If same car is moving with speed 1/3 of the reported speed, then it will stop after traveling how much distance? Okay, so it is going with let us take initial, I am taking this as v. Okay, let us take this as v. Now here, if the speed is v and the acceleration is the same, applying brakes, so acceleration is a. So v to 0, if it goes, how much distance it covered? 27 meters. Now here is saying, if the car is moving at speed 1/3, now if you apply brakes, then it will travel how much distance? Let us take s. So we need to find s. Again, we need to relate the distance and the speeds. So using the formula v square minus u square is equals to 2s. So for the first condition, final velocity 0 square minus initial velocity v square is equals to 2 into a acceleration into s, that is 27. Okay, now you may say, sir, but it's not mentioned here the acceleration is same. Now sometimes you have to use common sense. Okay, he is saying he is applying brakes. He is not mentioning uh, whether the acceleration is same or not, but it is understood that the acceleration is same here. He is applying the brakes similarly in both cases. So in second condition, 0 square v is 0, initial is v by 3. This is 2a into the distance s. Getting these two equations, divide these two. So simply divide these two. If you divide them, 2a is getting cancelled, and here also it will become 9 in the numerator. So 9 is equals to 27 by s, and I got s as 3. S as 3 meters. Okay. This was also based on the same formula. Now in 2D, let us talk about 2D. Now when we have constant acceleration, let us take in 2D. So what you can do is, you can separately write equations along x-axis, along y-axis. Okay, so along x-axis, whatever is the initial velocity, whatever is the acceleration is given, whatever is the final velocity is there, accordingly you relate that separately. Along y-axis also you relate that separately. These x-axis and y-axis, these are independent directions, okay, perpendicular to each other. So independent direction. When you are writing equations along x-axis, don't take the y-axis variables. When you are writing equation along y-axis, don't take the x-axis variable. Okay, let us read this question. You will understand more in a much better way here. Starting from the origin at t is equals to 0, initial velocity 5j meter per second, a particle moves in xy plane with a constant acceleration of this. Now here, what is this? This is my ax 10. This is my ay 4. And initial velocity is only along y-axis. This is my uy. What is ux? Ux is 0. At t, its coordinates are 20 comma y naught. I need to find what is t and y naught. So x coordinate becomes 20. Now I am writing equation only along x axis first. Okay, let us separate that. So first let us analyze motion along x axis. My ux is 0, ax is 10. Okay, when the position along x axis will become 20, so I'll say x is equals to ut plus half at square. So x is uxt, that is ux is 0, so 0 plus half at square. Acceleration I'll take as ax into t square. This x is my 20, so 20 is equals to 5 t square, and t comes out to be 2 seconds. We got t as 2, so one of the answer I got as 2. Now I need y naught. What will be my y coordinate? Okay, it's starting from origin, so initial x coordinate was 0. You may say, sir, whether we are getting displacement or position. So displacement, x is change. So my initial x, if I say, that is 0, therefore I am saying the final position will become like this. Okay, otherwise I will be writing this as x minus x naught, the final position minus initial position, because this is displacement part, na, s is equal to ut plus half at square. Therefore, now along y-axis if I write, so y naught also, it's starting from origin, so y naught is equals to uyt plus half ay into t square. What is uy? 5. What is t? T is 2 plus what is ay? Ay is 4 into 2 square 4. So this is 10 plus 8, 18 meter. So 2 and 18. Option D is there. So here we analyzed both the motions separately along x-axis and along y-axis. This is how you have to do. When you will learn projectile motion, the same way we will approach that. We'll see the motion along x-axis separately, see the motion along y-axis separately. See that what is the acceleration along x-axis, what is the initial velocity along x-axis, what is the final velocity, analyze that separately. Same thing along y-axis, see the acceleration, see the velocity, initial and final there, relate like that. What is the one thing that is common between the two? That is time. Okay, the time actually relates the two. Okay, so from here the time is 2 seconds. Here we put that 2 seconds because that time is relating both of these two, x coordinate and y coordinate. Getting it? Okay, straight line motion under gravity. Now this is one of the, I'll say, application of uniformly accelerated motion only. Particle is moving freely under gravity. There is acceleration due to gravity in the downward direction. So we write the equations for that. Okay, here the condition maybe a particle is projected vertically upward with some initial velocity. You need to find h max, you need to find the time of flight, or you need to find at what time it will reach this height, or like that. Okay, and then it may be like some particle is dropped from certain height or thrown downward or upward from certain height. So just you have to use the formula for uniformly accelerated motion considering the acceleration in the downward direction as g. Okay, now you may say, sir, acceleration is minus g or g? Many of the students are confused. Minus represent the direction. If you take upward direction positive, we will say acceleration is minus g. If you take downward direction as positive, we will say acceleration as plus g. Magnitude of the acceleration is g, and we know that is in the downward direction. Okay, so don't get confused with this thing, whether the acceleration is minus g or plus g. Getting it? Okay, let us take simple thing. We are throwing a ball with initial velocity u, and how it will go? You know that it will go to certain height like this, will come back. Now you may need to find what is this h. Let us take this simple thing. You already did that, but I'm just quickly brushing up your previous topics. So u projecting with upward certain velocity, when it reaches the maximum height, we know here the velocity becomes 0. I need to find how much is the displacement. Acceleration is in the downward direction g. Which formula should I use to find h? V square minus u square is equal to 2s, isn't it? I don't need time. So for v square minus u square is equal to 2as. Now here you need to consider which direction you are considering as positive, upward or downward. Okay, any of the direction you can consider, but accordingly write the signs of your variables. So I'm taking upward as my positive. So when I consider upward as positive, final velocity is 0, initial velocity is u square is equals to 2 into acceleration is in the downward direction, so minus g into what is the displacement here that I am considering as my h max. So h max, so from here I got h max as u square by 2g. If I ask you how much time it took to reach the maximum height, you may use formula v is equal to u plus at. What is v? V is 0. What is u? U was plus because it is in the upward direction, so plus u. Acceleration is minus g, downward as negative. So from here I got th max as u by g. You may find what is t flight. T flight is twice of, because the time it takes to go up, the same time it will take to come down. When the acceleration is constant, okay, then this thing happens. So 2 times of th max 2u by g. These are few of the standard things. Now if I say you, okay, this is a condition that a particle is thrown with some velocity u from a certain star whose height is h. Okay, so from a top of the building or like that, you are projecting it vertically with speed u. Now if I ask you in how much time it will come back, or few things like that, in how much time it will come back or fall to the ground, what is the time? So here some students, what they do is, first they will find how much time it will take to go to the top, and then they will find how much time it will take to come from top to bottom, and then separately add these two times and then solve. Need not do that. You can just do this simply in one equation. Now here I need time, so I'm using this equation s is equals to ut plus half at square. I'm considering upward as positive, taking this as 0, 0. So when it finally reaches down, what is the displacement? Minus h, because that is in the downward direction. So minus h is equals to, what is the initial velocity in the upward direction? So plus u. So u t, acceleration is minus g in the downward, so minus g by 2t square. Now this is a quadratic equation in t, you can solve for t. Okay, easy, not that difficult. Now he may ask you how much, let us take in how much time it will reach the top. So it's just the th max. Okay, that will become my u by g. That is clear. Now he may ask you in how much time it will be at a certain height. Let us take here. So it is reaching at that height 2 times. So again you will use this formula. You will get two solutions for t. Okay. So one time will be while going up, another time will be while coming down. And if I, let us take, ask you in what time it will reach here, you wrote this equation, you are solving, you will get 2t. So which one to accept? One time will be negative t. So don't accept negative, because time is positive. From t is equals to 0 we are throwing here, time is never negative. So here we will consider only the positive time solution that you will get. And many other similar type of variations can come. He may ask when it will reach at some point like this. Okay, or he may ask you what is the total height from the ground. He may ask you this also. Then you need to know what is this height, what is that? U square by 2g. What is this? H. So this will become h plus u square by 2g. Okay, so anything if he is asking, just you need to use the same three formulas, that's all. Now one more thing, let us take particle is dropped from certain height. Okay, let us take those things. Particle is dropped from certain height. This is h. It is falling down. Now if I ask you, what is the time when it reach here? It is dropped at t is equals to 0. When it will reach down? So which formula you will use? Again, we need to relate the displacement and the time. So which formula s is equals to ut plus half at square. So I'll use s is equals to ut plus half at square. Now considering downward as negative, upward as positive. So from here I dropped. So the displacement is minus h. So minus h is equals to u was 0. Acceleration is minus g. Time is equals to root 2h by g. So many times we directly remember this formula. If a particle is dropped from height h, the time it takes to reach the ground is root 2h by g. Now, if I see how much distance it covers in first second, let us do that exercise. So in first second, if I ask you how much distance, like in 1 second, 0 to 1, 0 to, let us take 1 second. So you'll write s is equals to ut plus half at square. U is 0, so half, just writing distance, half gt square. So this will become 5 meter. Now in second, how much distance it will cover? So you'll say the total distance it cover in 2 seconds minus in the first it covered. So this will become half g into t is 2. So 2 square minus in the first 5. How much is this? So this will become 20 minus 5 is 15 meter. Similarly, if I ask you in third second, this will become total distance in 3 seconds minus how much it covered in 2 seconds. this will come like this. And if you see the ratio, it will the ratio is 1 is to 3 is to 5 is to 7 is to 9 is to 11, and this we call as Galileo's ratio of odd numbers. Okay, so the distance in the first second and in the second ratio is 1 is to 3. Then further 1 is to 3 is to 5, further 1 is to 3 is to 5 is to 7, 1 is to 3 is to, and this ratio will be maintained like this. So all the odd numbers will come like this. Okay, just for like sometimes it is required, so I'm telling that. Okay, let us take some varieties of questions on this particular concept. A body projected vertically upward with a certain speed from the top of a tower reaches the ground in 1 second in t1. Okay, if it is projected vertically upward from the same point with the same speed, it reaches in t2. Time required to reach the ground if it is dropped from the top of the tower is, that is the third case, and the answers are in terms of t1, t2, like that. If I say case 1, it is thrown like this, it reaches the ground in t1 second. Case 2, thrown vertically downward with the same velocity. If the velocity was u here, it is u. Reaches the ground in t2 second. Okay, it will come down like this. Third, case 3, it is dropped. The height is the same. It's the same. Okay, so how much time it will take? So I know the formula. If it is dropped from height h, the time is root of 2h by g. But h is, we need to answer in terms of t1 and t2, not in terms of h. Now here what to do? Write the equations. For this I'm writing the equation taking upward as positive. Okay, taking upward as positive. So the displacement is minus h. So minus h is equals to u. It reaches ground at time t1. So u t1 minus g by 2 into t1 square. Now write the equation for the second case. I'm taking downward as positive here in this second case. So h is equals to u t2 plus half g t2 square. So don't get confused. I'm taking downward as positive. So this is plus h. U is plus here. G is plus. Acceleration is plus g, not minus g in this case. Got it? Getting it? I'm taking downward as positive. Any direction. Like if you take up downward as negative also I would have taken, then minus 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 will come. All three minus will get cancelled. Now from these two equations, what I need to do? I need to replace u because I need to relate t, h and g. This is what I need. So I'll replace u. How we can replace u? So I can equate u. From here if I write u, what it will become? Minus h by t1 plus g t1 by 2. Is it right? It will become here plus, yes, I divide with the g t1 by 2. This is right. Now if I write u from here, h by t2 minus g t2 by 2. Perfect. Equate the two because u and u, so equating 2, so it will become minus h by t1, and what I can do is, okay, so when I am equating, what I am doing is I'll take the g terms on the one side and h term on the other side. Okay, so g terms here it will become g by 2 and this will become t1, what it will become, t1 plus t2 is equal to h term. If I take on the other side, this will become h by h, I'll take common s, so it will become 1 by t2 plus 1 by t1. rotate like this, taking LCM, T1 plus T2 will become in the numerator. So T1 plus T2 will get cancelled from here, and what we will get? We will get G by 2 is equal to H by T1 T2. So from here, root 2H by G, if I write, what is this? 2H by G is T1 T2. So root 2H by G will become root of T1 T2. So while solving the equations, you have to be a bit smart. Otherwise, these questions are simple. But if you are going to solve them in a wrong way, it will take a lot of time. I replaced you here because I knew that in the final time expression, I don't need you. If I do a mistake, let us take, and I'm trying to solve T1 here, trying to solve T2 here, and then eventually trying to reach to the answer, that then it will take a lot of time. Time will be wasted. So these constant accelerated constant, or I'll say uniformly accelerated motion questions are not that difficult. Only thing is you need to put right equation. Okay, if you take some other equation, you can do, no problem, but it will take a lot of time. Okay, moving to next question. What it is? A ball is thrown vertically upward with a velocity of 19.6 from the top of tower. The ball strikes the ground after 6 seconds. The height from the ground to which the ball can rise will be k by 5, and we need to find the value of k. This is another simple question. Okay, thrown vertically upward with velocity 19.6. Let us take, this is my tower, and from here it is thrown up with 19.6 meter per second, reached the ground, and it reached at 6 seconds. Here G is given as 9.8. Okay, so by default we take G is equal to 10, but sometime it is mentioned, so you need to consider that also. So here 6 second he is reaching down. We need to find the height from the ground. We need to find this total h. Now here the data is very simple. Therefore, solving this question is easy. Why so? This velocity is 19.6. When it will reach the maximum height? U by G. What is that? 2 seconds. So I know it will reach maximum height at t is equal to 2 seconds. So how much time it will take to fall from maximum height to ground? 4 seconds. If a particle is dropped from the top, it takes 4 seconds to reach. How much distance it will cover to reach the ground? So you can just write half G 4 in square. This becomes my total height h. This total height I'm considering as h. Okay, getting it? I got 4 seconds it will take to fall. So just writing half G into 4 square, that will become my h, and half G is 9.8, 4 square is 16. Okay, this is my h. This becomes 9.8 into 8, and this is what? This is given as k by 5. So k is basically 40 into 9.8, or I'll say this is everything is right, yeah. So this is 98 into 4. How much is that? There is no mistake, I hope so. Everything is fine. Okay, so 339, 392. We got k as 392. Yes, everything is perfect. Calculations are perfect here. Okay, getting this concept? So many questions we did. I hope you are very clear with this thing. Now moving to graphs. So graph is also one of the important concept from where JEE Mains is asking questions continuously. Okay, very important topic I'll say, and it's not that difficult also to learn. If a graph question is there, hardly it takes few seconds to solve. Most of the questions are just straightforward. Just by seeing only you will solve it. Okay, so You should learn this topic, I'll say. This is important topic. Now, first of all, let us talk about position time graph. Now, if I relate position, so we know that we say v is equals to dx by dt. V is equals to dx by dt. It means velocity is, what is dx by dt? Differentiation of x with respect to t. It means slope of xt curve. So velocity is what? From here I got that velocity is slope of position time curve. This I got. Okay. And if I integrate on the other way, so dx is equals to v dt. Integration of dx is equals to integration of v dt. So what is integration of dx? Delta x. What is delta x? My displacement. So from here I can say that displacement is the area under velocity time curve. We'll come to this point when we'll come to the velocity curve. Anyways, let me write it. So displacement is the area under velocity time curve. Now if I ask you, this is x, this is t time, and let us take the curve is like this. What is the velocity? You'll say position is not changing with time, velocity is 0. Yes. Another thing, let us take. If it is straight line, maybe like this, it's a straight line. Straight line means slope is constant. It means velocity is constant. And here the slope is positive. It means velocity is constant and positive. Constant, and this is positive. On the other way, if let us take it as the position time curve is maybe like this. This is for this particular case. For this, if I say velocity is constant, it's a straight line, but the velocity is negative, slope is negative. So here the velocity is constant, but it is negative. What if the acceleration is constant? How the curve will look like if the acceleration is constant? If I say you acceleration is constant, so we know if acceleration is constant, my velocity will be of type u plus at, and the acceleration, if the displacement we write, that is of type ut plus half at square. So this is of parabolic in nature. Okay, this is of parabolic in nature. So if the acceleration is constant, it will come out to be parabola, and if acceleration is positive, it will be upward parabola. Acceleration is positive and constant. Okay, and if acceleration is negative constant, it will be downward parabola. You may say, sir, how we can say this acceleration is positive and negative here? You may check the slope, how the slope is changing. If you see here, the slope is initially negative. Here the slope is 0. Here the slope is positive. Negative, 0, positive. It is increasing. Velocity is increasing. Therefore, acceleration is positive. Here if you see, the slope is positive, then the slope is 0, then the slope is negative. Positive, 0, negative, decreasing. Slope is decreasing means acceleration is negative. Okay, so if it is upward parabola, acceleration is positive. Downward parabola, acceleration is negative. Getting it? Okay, great. Coming to question. Now here different position time curves are given to us. We have to check for corresponding velocity time curve. Okay. Let us go one by one. Let us go one by one first. A. It's a upward parabola. Acceleration is constant and positive. If the acceleration is constant, slope of velocity time curve is constant, means Vt curve will be a straight line. Vt curve will be a straight line and with a positive slope. Straight line with a positive slope. Second option. So for A we got 2. Now let us come to C first. If for CVD, see, xt curve is like this. Initial xt curve is a straight line, it means the velocity is constant. So initially the velocity is positive constant, then negative constant. Positive constant, then negative constant. Third, here xt is like the straight line and slope is positive. So velocity is constant and only positive. So first, now coming to this. Now here if you see, initially if I say try to see the velocity, okay, how the velocity is changing. The slope is greater in magnitude, okay, certainly it is negative, and it is with the time it is decreasing in magnitude. It's negative but it is decreasing in magnitude with time. So velocity is negative if you see, and with time it is decreasing in magnitude, so forth. So for B we are getting fourth. So we got 2 4 3 1. 2 4 3 1. Yeah, A is the correct match. And need not solve all the 4 such matrix matches coming. Just see which options are different. Okay, I need to check A because in 2 first A is 2, here A is 1. I'll need to check A. I checked A. So for A I got 2. Both are having 2. Need not solve for like I got A and C. These are correct. Okay, both are 2 now. Now just by checking B I can clarify, or just by checking C I can clarify. Don't solve for D because D is same. So just check for C. C was easy. We can check very quickly. We checked for C. We got that only A is correct. We can move ahead by saving time. Velocity time graph. So as I mentioned that V is equals to dx by dt. So dx is equals to v dt. Got from here that the displacement is area under the velocity time curve. Okay, displacement is area, integration means area. Okay, so area under vt curve. This we got. Then we wrote A as dv by dt. A as dv by dt. From here I can say acceleration is differentiation, rate of change of velocity with respect to time, means slope of the velocity time curve. So I'll say acceleration is slope of the velocity time curve. Acceleration is slope of velocity time curve. Got it? So this is what you need to understand from here. Okay, so if let us take velocity is constant or few things you will understand from here. Let us discuss that. If the velocity is like this, what you will say? Acceleration is 0, isn't it? Because slope is 0. If let us take the velocity is like this, you will say acceleration is constant because slope is constant for a straight line. So acceleration is constant here and slope is positive, so it's constant positive. On the other side, if let us take some curve like this, it is okay, then what we will say? It is constant and negative. And it is negative. And let us take if vt curve is not a straight line, then what? VT curve is not a straight line, then we will say that acceleration is not constant, acceleration is changing with time. Okay, and one more thing, as I discussed, some curve, let us take like this is given, and you need to find the displacement. So area under the curve is velocity, time curve is the displacement. Let us take, you have to find displacement till here. So we'll consider this complete area. Let us take this area is A1, this area is A2. So when we say displacement, you have to take the sign here. Velocity is negative, particle is traveling in the opposite direction, that distance will be that actually that is decreasing the displacement, that area you need to consider as negative. So A2, A1 minus A2. If you talk about distance, distance means you need the path length. Okay, whether this covered in the forward direction or in the backward direction, I need the path length. So I'll say A1 plus A2. This concept is very important. If you are confused in this, try to understand it clearly. Very important concept. Okay, questions are asked from here. So sometimes it is asked like tell the ratio of distance and displacement, or tell the distance, tell the displacement. So many students are confused in this, whether to consider positive or negative. So if it is displacement, you need to consider the sign. Negative will come for area which is on the negative side. Okay, when the velocity is negative. If you need to consider distance, just add all the areas, whether they are positive or negative. Okay, yeah, we got an example like this. Let us discuss this. From the VT graph shown the ratio of distance to displacement. So first of all, let us find the distance, and then we can find displacement. So we will find all the areas. Okay, let me do one by one. What is the area of this triangle? How much is this? So base is 5, height is 10, 1 by 2 into base into height, that will become 50 by 2, so 25. So this area is 25. Further, this is a rectangle. What is the area of this? 5 into 10, 50. So this area is 50. Then we are having a trapezium. This. How to write its area? 1 by 2 into sum of parallel sides into the distance between the parallel sides. If you know the formula, good. If you don't know the formula, you can like two shapes you can make, one triangle, one rectangle, and then you can find. Okay, so 1 by 2 into the sum of the parallel sides, so 10 plus 20 is 30, into the distance between the parallel sides. How much is that? 5. 75. For this, how much is the area? Base is how much? 5. Height is 20. 1 by 2 into 20 into 5, 50. Here area minus 50. Okay, or if I am writing magnitude, I may just write 50, but for distance and displacement, you need to consider the sign accordingly. The area is 50. Okay, so if I write the distance, what I'll do, I'll add all those things. So 25 plus 50 plus 75 plus 50 plus 50. How much is that? 75 plus 25 is 100. 100 plus 100, 200, 250. Okay, displacement. Consider the negative sign here. So 50 minus 50, that will become 0. Remaining will be 150. Need to find the ratio of distance to displacement. So 250 by 150. So 50 into 5, 50 into 3, 5 by 3. And two options are directly cancelled from here. Need not solve this question actually. Don't solve this question. Why? 3 by 5. Distance by displacement can be less than 1? No. 1 by 2. Is it possible? No. 1. Is it possible? No. Both are not equal, because its positive negative thing is there. Okay, both are not equal. Only one option is there. See, just mark C, move ahead. Now you have to be smart like this in mains. Don't solve this question. Just see, oh, A is not possible, B is not possible, D is not possible. Mark C, move ahead. In many questions, such things are there. If I see mains paper, many questions are like this. And sometimes there are complicated calculation. We spend so much time writing the area of this, 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 then area of this, summing up, finding the distance, finding the displacement, taking the ratio. Why spend so much time? If just options are saying that only C is correct, why you are spending so much time? So therefore I say, while solving the questions, go to the options, be a bit smart. If you are just able to mark the answer just by seeing the options, move ahead. Don't spend time. Don't spend time. Because what happens is, there are some questions where you need to invest time. And those difficult questions actually, I'll say, make the difference. They decides whether you are going to get 99 percentile or not. They decides actually. So much competition is there. Easy question everybody does. Okay, so you need to save time from the easy questions. You need to invest time on those questions which hardly few students will be able to do. When you will do that? When you save time from these type of questions. If you do that, so much time will be left. At the end, you know, there are 5 questions which are going to take a lot of time. Let me do at least 2. Let me do at least 3. And if all 5, good and well and good, I'll say. Okay, so this is the way actually I used to do in exam. So I remember, like, first of all I used to do chemistry. Okay, so it take hardly like 30 minutes quickly. Then I moved to the physics. Let us take, there are 25. In my time there was 30 questions. So let us take, I solved 25. 5 questions I can solve, but I know it will take time. I'm not going to invest as of now because I don't know like how much time will be left. So 5 questions will take a lot of time. I left them. Moving ahead, maths I did. Okay, let us take some questions also there. I left. Now coming back, now I have, let us take nearly 45 minutes. Now these 5 questions I'm very sure in physics will take time, but I'll solve them, all of them. I'll solve all of them. Now let us take 5 questions for in maths. I know 2 to 3 I'll be able to do. I'll do 2 to 3, and that actually make the difference. That one question is not one question. Actually what happens, like when you move closer, like there, like as if one question is correct, okay, your percentile changes. One question makes your selection into an IT, and like if you do a mistake, uh, then you need to reconsider the April attempt. Sometime it happens like this. Acceleration time graph, okay, AT curve. So first of all, A is equals to dv by dt, dv is equals to a dt integrated velocity v1 to v2 as time 0 to t. So what is this? v2 minus v1 is equals to what? Area under the curve. Area under acceleration time curve. Area under AT curve. Okay, so area under AT curve basically gives you what? It gives you the change in velocity. Try to understand. Don't say velocity. Don't say velocity. It gives you the change in velocity. When we are integrating, it is from v2 to v1. It gives you the change in velocity. Okay, if the velocity time graph has the shape, this shape is given, what would be the speed of the corresponding acceleration time, shape, not speed, shape of the corresponding acceleration time graph. Vt curve is given, the slope is negative, straight line. So acceleration is negative, constant. Acceleration is negative and this is constant. Similarly here, acceleration is positive, slope is positive and constant. First acceleration is negative, constant, then acceleration is positive, constant. We got option A. we moved ahead. Other graphs. So sometimes in mains, not very frequently, okay, sometimes I'll say some other graphs are given. Let us take Vx curve is given, Ax curve is given, or V square x is curve is given, or 1 by x, 1 by t. Sometimes these odd types of curves are given, okay, but they are very easy provided your concepts are clear. Let us take some Vx curve is given, and the shape is, you may consider something like this, and then you need to draw Ax curve or anything like that. So what you need to do in these type of cases, just go with the core concepts. First of all, write the equation of this curve. So I'll write the equation of this curve. This is a straight line, so V is equals to mx plus c type of equation will come. M is the slope, c is the intercept. This type of equation will come. If I had to find acceleration, I know A is equals to v dv by dx, d by dx of mx plus c, okay, like this I can do. So from here you'll get it is mx plus c, v is mx plus c into here m, you got it like this. Or let us take, you have to relate position and time, so you can write v as dx by dt, mx plus c, dx mx plus c dt integrated. Getting it? Or you have some other type of curves. I took Vx here, let us take Ax curve is there, and then you have to relate. So then you go with the core concepts. Don't see area, this and that. Go with the core concepts. Write the equation. See what you need to, if you have to uh, go for Ax curve or like that, write the equation, differentiate to get the acceleration. You have to get xt, write the equation, differentiate it like this. Or many times what happens, you, if you be a bit smart, like the way I showed you previously, if you're a bit smart, you can even directly mark the options. Like sometime what happens is the acceleration is positive, it is positive, not constant, okay, it's positive, and you know that. So Ax curve is there, only one of the option is having positive acceleration, all three are saying some positive, some negative, so just mark one and move ahead, that's all. Okay, so may not go for the exact solution also many times. Okay, let us do this question. The velocity displacement graph of particle is shown in the figure. This is Vx. The acceleration displacement of the same particle is represented by. Okay, now we need to do the same way as I mentioned. This is Vx. How to write Ax? So first of all, write the velocity equation from here. So V is equals to mx plus c. What is the slope? It's negative of minus v naught by x naught. M into x plus c. What is intercept? That is plus v naught. So plus v naught. Now we need to find Ax curve. So we know acceleration is v dv by dx. Okay, so write it again. So minus v naught by x naught into x plus v naught, and if you differentiate this with respect to x, you'll get minus v naught by x naught. So what it will become? V naught by x naught whole square into x minus, this is minus v naught square by x naught. So here I am getting intercept as negative and slope as positive. Intercept as negative and slope as positive. You see? Got it? Yes, intercept is negative and slope is positive. Okay, now we are moving to projectile motion. This is, I'll say, one of the I'll say key concepts in physics, and many of you already understand the key concepts of projectile motion. And many times if we see in collision, some projectile is included there. In let us take motion of a charged particle, some projectile is included there. The magnetic field is there, there also few things are there. So you need to understand this, and understanding is not that difficult. Why so? Because you need to analyze both the motions separately. I'll show you how I am saying. Let us draw x-axis and y-axis first. This is my y-axis. Let us take. This is my x-axis, and okay. Anyways, let me take yellow color itself. So a particle is projected, and it went somewhat like this. It is projected with some initial velocity v at an angle theta, or you may consider this velocity to be u. Okay, now one of the few of the fundamental things are: tell the time of flight, tell the maximum height, tell the time it takes to reach the maximum height, tell the horizontal range. These are just fundamental things. Let us do those things first. So I am saying we can analyze motion along x-axis and y-axis separately. X-axis and y-axis separately. Let us write the few things first. The initial velocity along y-axis, what is that? Take the component of initial velocity along y-axis, u sine theta. Initial velocity along x-axis, take the component along x-axis, u cos theta. What is the acceleration along y-axis? I'm taking upward as positive, so it's downward g, so minus g. Acceleration along x-axis, it is 0. Getting it? Anytime if I write the velocity along y-axis, v is equal to u plus at, so uy, that is u sine theta minus gt. Anytime if I write velocity along x-axis, that is going to remain the same because the acceleration is 0 always. Anytime if I write the displacement along y-axis, ut plus half at square, so u sine theta, initial velocity t minus half g t square. Anytime the displacement along x-axis, velocity is constant, so ux into t. These things are very clear to us. Now, when it reaches the maximum height, which velocity is 0? Ux or uy? Uy is 0 because it's not going upward, it is moving only horizontal direction. So here my Vy is 0, Vx is the same u cos theta. So to get the time to reach the maximum height, I'll put Vy as 0. And if I put Vy as 0, my Th, what it will become? U sine theta by g. The time it takes to reach the maximum height. What is t flight? The same time it will take to come back from the maximum height to the ground. So t flight is twice of Th, 2u sine theta by g. How much is this h max? This height, how much is this h height? So I know the t, I need to find the y value. What is y at this time? I'll put t here to get h. And if you put t, what it will become? Y is equals to u sine theta t minus u sine theta by g minus half g u sine theta by g square. So what it will become? U square sine square theta by 2g, and this becomes my h. Okay. And if I ask you, how much is this horizontal range? R. So this is the distance it covers in the horizontal direction. In duration what? In duration of t flight. So I'll say R is equals to ux into t flight. Let us do that. Ux is u cos theta. T flight is 2u sine theta by g. So 2 sine theta cos theta is sine 2 theta. This becomes u square sine 2 theta by g. This becomes my range. So all these formulas you can remember, if you might be already remembering that, if not, you can remember them. These are frequently used. Now these are the things which are fundamental, like if, like sometime it is asked, if it is asked you can directly mark. What if some things are asked which are not just formula, then you need to apply the fundamental equation. If it asks you at what time it will reach a particular height, what you will do, you'll use this equation. At what time it will reach a horizontal, let us take some horizontal distance, then again you need to that equation. And at what time, let us take what is the velocity, find ux, find uy. At that particular time, what is the angle of the velocity with the horizontal, tan theta is vy by vx, find vy, find vx, divide that. So these all things you need to do. Okay, now fundamental few more things. When the range is maximum when this sine to theta term is maximum. It means sine of 90, because sine maximum is at sine 90, sine of 90, it means 2 theta is 90, theta is 45. So range is maximum when angle of projection is 45 degree, and that maximum range will become u square by g. Okay, now equation of trajectory. Equation of trajectory means what is the equation of the path the particle is following. Now I know x equation. What is x? We already wrote u cos theta into t. What is y? Y was u sin theta, t minus half gt square. I need xy relation. So from x, I'll put time on the right side. This was u sin theta t actually. Okay. So if I write t from here, this is x by u cos theta. I'll put t here in this equation. So what y will become? U sin theta into t as x by u cos theta minus half g x by u cos theta square, and this will become x tan theta, you will get cancelled, minus gx square by 2u square cos square theta. This is my y. Do you need to remember this equation? Yes, I'll say you need to remember it. Okay, simple thing. Moving further, we have some questions on projectile motion. Let us do these questions. Projectiles A and B are thrown at angles of 45 degree and 60 degree with vertical. Now, one more thing I should tell you from here. Yeah. Like if let us take sine to theta is there. If two projectiles having the same value of sine to theta have the same range, isn't it? And we know that sine theta is sine 180 minus theta. Okay, so let us take two angles, theta 1 and theta 2. Can they have the same range when the speed is same? Yes. So how? You see, u square sine 2 theta 1 by g is equals to u square sine 2 theta 2 by g. So I'll say sine 2 theta 1 is equals to sine 2 theta 2, and we know that sine theta is sine 180 minus theta. So 2 theta 1 is 180 minus 2 theta 2. So from here I got theta 1 plus theta 2 is equals to 90. So if two complementary angles are there, the range will be same. If you project a projectile at 60 degree and 30 degree, range will be same. If you project at 15 degree and 75 degree, the range will be same. If you project at, let us take 37 degree, 53 degree, the range will be same. Angles are complementary, range will be same. Okay, now this is okay, this is a question when it is thrown from top of a tower, but this question is simple, not that difficult. Let us read. Projectile A and B are thrown at angle 45 degree and 60 degree vertically respectively from top of 400-meter high tower. Now when there are some varieties are there in projectile motion, from some height it is thrown at some particular angle. Don't use these the formula of maximum height and the range, no. But the fundamentals, how x will vary, how y will vary, they will remain the same. Okay, so you can use the fundamental equations there to solve. Here it is saying two projectile A and B are thrown at an angle 45 degree and 60 degree from vertical from top of 400-meter high tower. So one is 45 degree. Let us take this as V1. Another is 60 degree. Let us take V2. If the range and time of flight are same, range is same, time of flight is same. Now if I say time of flight is same, when the time of flight will be same? Time of flight depends on what? Velocity along y-axis, it depends only on that. Okay, so if time of flight is same, it means velocity along y-axis is same. Let us do that. Velocity along y-axis, v2 sine 60 is v1 sine 45. Velocity along y-axis is same. Now range is same. What is range? Range is t flight into ux. T flight is same, it means ux is same, then only the range is same. So horizontal component v2 cos 60 is equals to v1 cos 45. Is it possible? Take the v1 v2 ratio from here, take the v1 v2 ratio from here, it's different. So that's not possible. I'll say it's not possible. This condition is not possible. None of these. Just I use fundamentals. I'm not using any formula, and many times it happens formula based questions will not come because NTA know which formula you are going to apply. Many times he asks also, but they will not ask, they will make some change. So what you need to do, you have to understand the concept. Next question. Okay, here equation of trajectory is given to us. The trajectory of projectile projected from ground is given as y is equals to x minus x square by 20. X and y are measured in meters. The maximum height attained by the projectile will be. I need to find h max. Now, but trajectory equation is given. Let us write the standard equation of trajectory and then we will see what are those variables are. So, I know the standard equation y is equals to x tan theta minus gx square by 2u square cos square theta. This we know. Let us match it now. X variable, x coefficient is tan theta. Here that is 1. So, I will say tan theta is 1. With x square it is 1 by 20. So, this is 1 by 20. So, I will say 2u square cos square theta by g is 20. Now, tan theta is 1 means theta is 45. If theta is 45, so it will become 2u square cos square 45 by g. This is 20. Now, h max. What is the formula of h max? H I know, that is u square sine square theta by 2g. Means u square sine square 45. What is that? 1 by 2 by 2g. So 4g. Getting it? And from here if I find this is 1 by 2. So u square by g is 20. So I'll put it here. U square by g is 20. So 20 by 4, that is 5. Option A. That is 5. Okay. So equation of trajectory we know, we need to match that with the standard trajectory equation, and that's all. We know the coefficients, from there we match the coefficients, we got the like whatever we need to find H max, that's all. Okay. Next, a projectile is projected at an angle 30° from horizontal with initial velocity 40 meter per second. The velocity of the projectile at t is equal to 2 seconds from the start will be. Okay, so I'm giving this question for you. Take a pause in this video, solve this and then come back. I hope you are back now. Okay, so after 2 seconds you need to find the velocity. The particle is projected with 40 meter per second. Okay, so 40 meter per second at an angle of 30°. Write the horizontal and vertical components. This is 40, this is 40 cos 30. Yeah. What is 40 cos 30? 20 root 3. This is 40 sin 30. What is that? 20. After 2 seconds, ux is not going to change. This will remain the same. I need to find just Vy. What is Vy? Vy is Uy minus Gt. 20 minus G, that is 10 into 2, that is 0. Vy becomes 0. Only ux will be there. Only my horizontal component velocity will be there, that is my Vx. 20 root 3. So the final velocity will be 20 root 3, that is option A. Now this is not a standard question. You may say, sir, which formula to apply? No, don't apply formula, just understand the concept. Understand the concept. Okay, and actually this is at maximum height. Previously, if we go, we wrote here, when it is at maximum height, only horizontal velocity will be there, that is u cos theta. Sometimes it is asked what is the kinetic energy at the maximum height. You know the velocity, you can find the kinetic energy also. Okay, now different cases of projectile motion. What happens sometimes, a particle is projected from certain height. Let us take it as this, as in this case it is projected horizontally, some with some velocity. Let us take with some velocity u, it is projected. Now different things might be asked. How much time it will take to reach the ground? What is this time? This is projected at t is equals to 0. What is this range? Okay, and few more other things it may ask. So in how much time? So see the motion separately along x-axis and y-axis. Along y-axis you see, is there any initial velocity? No. What is the acceleration? G in the downward direction. How much distance it has to fall? H. How much time it will take? Root 2 h by g. Simply along y-axis I show this and write it. Now what is range? Range is how much distance it covered in duration. Duration I know, root 2 h by g. So r will be my velocity u into root of 2 h by g. Simple. What if it is projected at certain angle? Okay, let us take it is projected with certain angle at some angle theta. This height is h. Now what will happen? It will go somewhat like this. Then what you need to do? Then again analyze the motion separately. This is your ux, u cos theta. This is a uy, u sin theta. Along x direction there is only what? Velocity, that is constant, acceleration is 0. Along y-axis, acceleration in the downward direction. So along x-axis if you write the formula, so you will say that the range, this will be u cos theta into t flight. Now how to find t flight? By writing the formula along y-axis. I know along y-axis the total displacement will be minus h when it will reach the ground. So I'll say minus h is equals to u sin theta into t flight minus half g t flight square. From there get t flight, put it here. Getting it? If let us take this angle is in the downward direction, so your y velocity will become negative. x velocity will remain the same if this is minus theta. Okay, so different conditions can come. Even I'll say there can be some like it is projected on an inclined plane also. We'll come to that basically. After this will come. Let us solve this question. A body of mass m thrown horizontally with velocity v from top of tower of height h touches the ground at a distance of 100 meter. Okay. With velocity v touches the tower at 100 meter, and this height h is given, h. A body of mass 2m thrown at velocity v by 2 from top of tower of height 4h. Now next case, the height is greater. Let us take this as 4h. 4h. And it is projected now, reach somewhat here, will touch the tower at how much distance? This we have to find. Okay, first thing, nothing will depend on the mass. Okay, so mass changes, nothing will change, the trajectory will remain the same. Next thing, here the speed is same, here the speed is same, v only. What is changing? T flight is changing. Here T flight root 2h by g. Here my T flight Tf dash will become root of 2 into 4h by g. So T flight is getting twice. If T flight is getting twice, R will get twice because R is u into T flight. Horizontal velocity is not changing. T flight is getting twice, so this will become 200. Got answer as 200. Things are not complicated. You may say, sir, here from top of a tower we are projecting. Things are not complicated. It's just simple. If your core concepts are clear, you can easily solve this question just in few seconds. I was drawing the diagrams, I was writing everything just to show you, okay, just to make you understand the concept. Otherwise, in exam, I'll not do this. I'll just read the question, mark the answer. I know T flight is getting twice, range will get twice, mark the answer, move ahead. Different cases of projectile. Now here on an inclined plane, this is, now in such cases, now in mains, these questions are not asked, okay, projectile on inclined plane, but for conceptual thing, I'm telling you how to solve such questions. You'll take two directions. This is my x, this is my y, perpendicular. One along the plane, another perpendicular to the plane. Now take the component of acceleration along these directions. This is my g in the downward direction. So along this acceleration will be g sine alpha. Along this it will become g cos alpha. So here if I write ax, that is minus g sine alpha, ay, that is minus g cos alpha. Okay, and similarly take the component of this u. My ux will be u cos of theta minus alpha. This angle is theta minus alpha. Uy is u sine of theta minus alpha. Here acceleration are along both the directions, so you need to consider that. Now you use the formula for uniformly accelerated motion along x-axis and along y-axis and solve for the same. Getting it? So nothing confusing is here. Just understand that he'll change the why I change this axis, why not this axis and this y-axis? Because I need to find the distance along this. Okay, therefore I considered this as my x-axis, this as my y-axis, perpendicular to that. Okay. Radius of curvature. Now what happens, many times questions are asked like a projectile is projected at some angle, find the radius of curvature when it is projected, or find the radius of curvature when it is the maximum height. When we will come to circular motion, we will discuss that. For let us take here the path is just when it is at the top is of this like circle, and this r becomes the radius of curvature. Like if instantaneously, let us take in between also, if I need to find what is the radius of curvature of the curve at this point. So if at that particular you can say here instant, so if you make the circle, that arc that will become the part of this circle, this arc will become the part of this circle. Okay, meaning now you need to find the radius of that particular circle. It's the meaning of radius of curvature. Now when we'll come to circular motion, we'll see that centripetal acceleration is v square by r. Okay, the centripetal acceleration is also our perpendicular component of the acceleration. So r is v square by a centripetal or like the component of the acceleration which is perpendicular to the velocity. Okay, this is component of g, perpendicular to velocity. Is this asked in mains? No, it's not asked. I am just telling you for conceptual clarity. Maybe asked, it's not asked much. Okay, component of g perpendicular to velocity. So initially, like here, if you need to find, how you'll write that? G is in the downward direction. This angle is theta. So this component is g cos of theta. So here it will become, velocity is v, so it will become u. Okay, so it will become here. If I write here, that will become u square by what is that? R. It will u square by, yeah, the perpendicular component, that is g cos theta. Okay, so this is my g sin theta, this is my g cos theta. How I took the component of g? This angle is theta, this angle is theta, this 90 minus theta, this again is theta. Getting it? This is radius in this case, not general formula. This is not the general formula. Similarly, here if you have to find, so this is u cos theta, this is g. Here the acceleration is g only in this direction. So for this particular case, if I write, so u cos theta square by g. Okay, but although it is not much asked, I just wrote it so that you have better understanding of the concepts. Now we are moving to the next topic, that is relative motion. Generally when the equations are given, equation are given with respect to ground. Let us take some velocity is given. So if you say that a car is moving with velocity 50 meter per second. So it's I'll understand that this 50 meter per second velocity is with respect to ground. Okay, that's a general thing. Okay, so there my frame of reference is ground. Now let us take, you are moving in a bike, okay, moving in the same direction with velocity 20 meter per second, and then if you will see the car will be moving slowly, isn't it? And if you move with the same velocity with that of the car, you will see the car is stationary, isn't it? Car is moving with 50, you are moving with 50, you will see, look at the car, you will see car is here only, it is at rest. It means what? You are seeing the car at rest, not that the person who is standing on the ground he is seeing. No, you are seeing at the car at the rest. Why so? It means the relative velocity of the car with respect to you is zero. That is the concept of relative velocity. Okay, so relative velocity means, let us take, this is particle A having some velocity VA, this is particle B having some velocity VB in some direction. If I want to write velocity of A with respect to B, what does it mean? With respect to B means B is your frame of reference. B is seeing the velocity B sees. Okay, it means velocity of A, okay, the velocity of A that B sees, okay, seen by B. I'll say velocity of A seen by B, because B is moving, therefore we have to write like this. So what is this? This is velocity of A minus the velocity of B. Velocity of A with respect to B. If I say other way, velocity of B with respect to A, so this is velocity of B minus velocity of A. So, and I'll say this is velocity of B seen by A. This is by here. Now this is relative velocity. If I talk about relative acceleration, that is also the same way. If let us take A is having some acceleration in particular direction, B is having some acceleration in particular direction, you will say acceleration of A with respect to B is acceleration of A minus acceleration of B. Similarly, acceleration of B with respect to A, just the opposite. So minus of acceleration of A with respect to B. This is minus of that. Okay, so I can write this is minus of velocity of A with respect to B. Similarly, I can say relative position also. So if I define positions vector also, so if I say position of A with respect to B, this is position of A minus position of B. Just I am changing my frame of reference. If I say position of B with respect to A, this is minus like this. Okay. So what is why this relative concept is there? Why it is used? It helps to solve many questions very easily as compared to like frame of reference of ground. We will see some questions like that. And sometimes we have to analyze like let us take you are observing a motion but you are not stationary. Okay, you are observing a motion but you are also moving, then there will be defined the relative acceleration, the relative velocity, the relative positions. Then you have to write the equations in these relative terms. Okay, when you write the equations, you'll write in term of relative. You can write all the things in relative terms like relative velocity, relative position, relative accelerations, and accordingly apply the equations to solve it. We'll come to such questions, you'll understand better way. Okay, got it? Hope so. Let us do a question. A fighter jet is flying horizontally at a certain at a certain height, I think. Yeah, at a certain height with a speed of 20 meter per second. When it passes directly overhead an anti-aircraft gun, a bullet is fired from the gun at an angle theta with the horizontal to hit the jet. If the bullet speed is 400 meter per second, the value of theta should be. Now the jet is, let us take here, and this jet is moving with velocity 200 meter per second. This is certain height. You are firing a bullet at some angle theta, and this velocity is 400 meter per second. Now this bullet should finally hit the jet. What should be theta? Now when it can hit the jet? Okay, when they travel the same horizontal distance, isn't it? If like they are on the vertical line here, so if they have to hit here, I'll say whatever horizontal distance this bullet covered, same horizontal distance the aircraft cover. Time is the same. Time is the same. Horizontal acceleration is not there. Both are having horizontal velocity to be constant. What does it mean? They should have the same horizontal velocity, then only they will cover the same horizontal distance, isn't it? Their horizontal velocity should be same. Okay, so if the horizontal velocity has to be same, what is the horizontal velocity of aircraft? 200. What is the horizontal velocity of this? 400 cos theta. What is theta from here? 60 degree. What it is asking? Theta 60. Getting it? Along y, if you see, you will say yes, along y it should cover this h distance, and accordingly we can write that equation, but that is not needed. He's just asking theta, I wrote it. Okay, so sit on the frame of, you can say let us take bullet or the aircraft. With respect to aircraft, how much horizontal distance it is covering? 0. So what should be the relative velocity of the bullet in the horizontal direction with respect to aircraft? 0. It means both horizontal velocity should be same. Yes, from relative concept we can say this. Now relative motion under gravity. Sometimes some question is there. Let us take from this height, this ball is thrown with some velocity. At the same time, this ball is thrown upward with some velocity. Where they will meet, at what time they will meet. These type of questions can be very easily solved if we use relative concept. Why? The point is why? Because acceleration of both the balls. Let us take this is ball A, this is ball B. What is acceleration of ball A? You will say, sir, that is minus g, j cap. What is acceleration? J cap downward direction. So I am just taking upward as positive. So downward direction is minus. Okay. So along y, so minus j cap I wrote. What is acceleration of B? Minus g j cap. What is acceleration of A with respect to B? 0. So if you set in on one of the ball and you observe the motion of other ball, it will be moving with uniform velocity. It will be moving with uniform velocity. It's not going to change. Motion is so much easy. Let us take, if you have to find how much time it will take, if this height is h, this initial speed, let us take are u1, u2. So with respect to A, you will see its speed is u1 plus u2. You will say time will be h divided by u1 plus u2. Okay. And yes, this u1 plus u2, even at a intermediate instant, if you find the relative velocity, that will not change. Relative velocity will remain constant here. Why so? Because the relative acceleration is 0. Okay. So relative velocity is going to remain constant. Come to the question. Ball A is placed at top of 180-meter tower. Okay. Ball B is released from top at t is equals to 0 second. So this is 180-meter tower. Ball A is released. Okay, ball A is released at t is equals to 0. So here it is released. Ball B is thrown vertically upward from the bottom of the tower with an initial velocity u at the same instant, means at t is equals to 0 only, ball B is thrown up. After a certain time, both the balls meet 100 meter above the ground. Matlab, means here 100 meter above the ground, they collide. Oh, after a certain time, yeah, okay, find the velocity value of u. So this was thrown with u. Ball B is thrown vertically upward. I think here it should be mentioned. Okay, it's mentioned with initial speed u. Now, if you solve this question normally, it will take you more time. If you solve this question with relative concept, it will take you very less time. How? I am observing the motion of B with respect to A. What is velocity of B with respect to A? That is u only. That is u only upward, always constant. How much distance he is covering with respect to this? It is striking it, A. So if you sit on A, you will say it covered 100-meter distance. He is considering himself to be stationary. With respect to A, it covered how much distance? Because A is stationary, na? With respect to means I took that as stationary. It covered 100-meter distance. So the time it will take is equals to relative distance, whatever it covered, relative distance covered, divided by relative velocity, 100 by u. Sorry, 180, not 100. I did a mistake in explaining. It is total distance is 180 meter. Total distance is 180 meter. Okay, so with respect to ball A, what is the initial separation? 180. What is the final separation? 0 with respect to A. So with respect to A, how much it covered? 180 meter. So it covered 180 meter. So this is 180 by u. This becomes my time. Okay, and in this time, he is saying this collision happened at 100 meter. It means in this time, how much it fall? 80 meter from rest. From rest, how much time it takes to fall 80 meter? So 80 is equals to half gt square. This equation I wrote in ground frame. Okay, so from here I got t as 4 seconds. If t is 4 seconds, put t is equals to 4 in this. So 180 by u is equals to 4. From here I got u as 45 meter per second. See, this was the relative concept here. Just take relative acceleration to be 0. See how much distance relatively it covered. Okay, like that. Relative, now here river swimming problem. So let us take a person is swimming, okay, in the direction of the river or in the opposite direction of the river. Then how you need to consider the velocities. Let us take river is flowing towards the right with velocity v river, and this person is swimming. It will, when it is swimming, it will have its swimming speed, and it is swimming with respect to the water. Okay, let us take a person, if he is swimming in lake, he is swimming with 5 meter per second. So when he is swimming in river, let us take river is flowing with 10 meter per second, so its speed will become 15. Okay, 5 with respect to river, he will swim with 5, and river is swimming with 15, so 5 plus 15 in the same direction. Got 5 plus 10, like that, 5 plus 10, river is with 10, man is with 5, so it becomes 15 meter per second. So I am saying that the speed of the man is given with respect to water with which he can swim. This is velocity of man with respect to river. Okay, this is velocity of man with respect to river, means this is velocity with which the person can swim. Velocity with which person can swim in stationary water. Okay. Sorry. Got it? Now, if I ask you with respect to water, if it is moving in downstream, so downstream, both the velocities will add. I'll say velocity of man with respect to ground, it will become velocity of man with respect to river or water, whatever it is, plus velocity of river. And upstream, it will become minus simply. Okay, so sometime it is given this much time it takes to go down the stream with and this much time it takes to come back, the distance is given and few other things are given. So like that you can write the equations to solve. Next is river crossing problems. Now we are coming to the actual problems in relative velocity, means river crossing, the rainman problems. These problems are frequently asked in JEE mains. Okay, so these concepts you need to understand very clearly. Let us take a river is there. This river is flowing towards the right, V river. A person is here. Okay, and he want to cross the river. Now there may be different conditions. You may ask, sir, how he want to cross? Whether he want to cross just straight, means with zero drift in the direction, or whether he want to cross in minimum time, or he want to cross along a certain path. There may be different conditions. So let us take the first condition, minimum time. Now here you have to understand the same concept. There are two velocities. One is the velocity of river, another is velocity with which the person swims with respect to the river. Understand? Like let us take, the person is swimming in this direction, but will he reach directly opposite point? No. Why? Because the river is moving. It will make him move somewhat like this. So he will move somewhat like this. Why so? Why is moving in this direction? Because river is having some velocity. So the velocity resultant that will come, that will be sum of the velocity of the man swimming plus the velocity of the river. Okay, that velocity with which the man is swimming or man can swim, that we say velocity of the man with respect to river or with respect to water. Okay, so he can make that velocity in any particular direction, but when he will swim, the velocity of river will add up to give him the resultant direction. Getting it? So minimum time condition, when I'm saying he can put his velocity of man with respect to river in any of the direction. Let us take one thing here, the width of the river as d. Width of the river, let me take as w. This is w. Now the person can move in this direction, can swim. He can swim in this direction, and he can swim in this direction or in any other direction. And when he will swim, the velocity of river also will add up, and he will move in the resultant direction, somewhat like this. Okay, so how he should swim so that he can cross the river in minimum time? To cross the river in minimum time, let me take the shapes. Yeah, this is y-axis. Okay, this is x-axis. Now to move, we have to move along the y direction. I just want to cross in the minimum time. So along y-axis, my velocity should come maximum. River is giving the horizontal velocity only, it's not giving the vertical velocity. To decrease the time, I need y component of velocity to be maximum. So what I will do, I'll make the man swim in this direction. So velocity of man with respect to river, he will swim in this direction. This is velocity of man with respect to river. But will he reach directly opposite? No. Why so? River is also there. This is velocity of river, and the resultant of the two, we'll say resultant of the two, how? Resultant of this vector and this, it will come somewhat in this direction, and he will reach somewhat here. This becomes my drift. Okay, how much time it takes? I'll say time it takes to cover is the width of the river, the displacement along y-axis divided by the velocity along y-axis, this. How much is the drift? You will say in horizontal direction the velocity is only the velocity of river, so drift is the velocity of river into the time, this. Okay, so this becomes the minimum time condition. Now next condition is what? That is of zero drift. Zero drift means the person want to reach just the directly opposite point. Okay, just a point that is directly opposite. This is my V river. Now he want to start from A, he want to reach B. How he should swim? Should he swim somewhat in this direction? No. If we swim in this direction, this velocity will add up, he'll move further away. So if we want to reach B, he should swim somewhat in this direction such that the horizontal component will cancel and he will move in this direction from A to B. Resultant, he will move from A to B. Okay, so he will put his velocity of man with respect to river somewhat at an angle theta such that he moves along AB. When he will move along AB, when the horizontal components of the velocity are cancelled, V river is this horizontal component. So the horizontal component of this v man with respect to river should cancel v river, then only the resultant will be vertical. So what is this? This is velocity of man with respect to river sine theta. These two components needs to cancel each other, then only the person will move in the upward direction like this with a velocity of man with respect to river cos theta. So the conditions for zero drift is velocity of man with respect to river sine theta is equals to velocity of river. So sine theta with the vertical I got velocity of river divided by velocity of man with respect to river. In the question you will be given velocity of man with respect to river and velocity of river. They will ask you sine theta. You can solve like that. Okay. And how much time it will take to cross? Time is equals to the width of the river W divided by the vertical velocity, which is velocity of man with respect to river into cos theta. How you can put cos theta? From here you can put, this is sine theta, you can find cos theta from there to put there. Okay, now here he is reaching here, so here my drift becomes 0. And for this, sine theta is less than 1. It is only possible when velocity of man with respect to river is greater than velocity of river. Okay, one more thing. Let us take the person need to move in a particular direction. Okay, so swimming in some particular direction. In a particular direction. Swimming in a particular direction means, let us take the person is here and it is given in the question that the person should reach to a particular point. Okay, this B, this is A. Now he will ask you in which direction he should swim. Now only thing is, I'll say he should swim in such a direction that resultant velocity comes in this direction. The resultant of which two velocities? Velocity of man with respect to river and velocity of river. This is velocity of river. Let me write with different color. This is velocity of river. He should swim in some particular direction. Let us take, he swim in this direction. It's not just perpendicular. It may be somewhat like this, you may say. This is velocity of man with respect to river. The resultant of these two vectors, should come along this direction. When it will come? When the perpendicular components are cancelled. When, let us take, this angle is alpha, this angle is theta. When this perpendicular component is VR sine theta and this is V velocity of man with respect to river sine alpha. When these two cancel each other, when this cancels this, then only the resultant will be only along that direction. So for to swim in that direction, I'll say velocity of man with respect to river sine alpha is equal to velocity of river into sine theta. Getting this concept? Okay. Now, the speed of a swimmer is 4 km/h in still water. If the swimmer makes his stroke normal to the flow means minimum time condition. Okay, width is given that it reaches a point 750 meter down the stream, means that is my drift, the speed of the river is. Now first of all I'll find time. Okay, first of all I'll find time. What is time? Time will be what is the width of the river, how much is that, 1 kilometer, divided by what is the velocity of man with respect to river. So this is the speed of swimming, this is velocity of man with respect to the river, so this is 4, this much is my time. Drift will be velocity of river into time. What is velocity of river? That we need to find. What is drift? Drift is 750 meter. Drift is 750. 750 means 3 by 4 kilometer. Time is 1 by 4 hour. So from here I got V river as 3 kilometer per hour. This is 3. Okay. Another question, the stream of a river is flowing with a speed of 2 km per hour. A swimmer can swim. This is velocity of swimmer with respect to water or the river. This is velocity of river. What should be the direction of the swimmer with respect to flow of the river to cross the river? So here zero drift condition. Zero drift, we know this angle theta, here sin theta is equals to velocity of river divided by velocity of man with respect to river. What is that? 2 and this is 4. This is 1 by 2. Sin theta 1 by 2 means theta is 30. So this theta we got 30. And he is asking the angle with respect to flow of the river. So means flow is towards the right. So total this angle. How much is that? 30 plus 90. So this will become 120 degrees. That is option D. Okay, zero drift condition. A swimmer wants to cross the river from A to B. Okay, you want to reach B, making an angle 30 degree here. This AB is making with the flow. The magnitude of velocity of the swimmer is same as that of the river. The angle theta should be. Now, how to find this theta? The component of velocity perpendicular to this line AB should cancel. This is velocity of river. The perpendicular to line AB, the component of velocity of river is V river sin 30. Now this is velocity of man with respect to river. The perpendicular component is velocity of man with respect to river sin theta. Equate both of them because then only they will cancel. So sin theta is equals to velocity of river sin 30. Here it is mentioned that the magnitude of velocity of swimmer is same as that of the river. So these two are equal. It means theta is equals 30. So we got this as 30. Easy. Now rainman problems. Rain is falling with some velocity. You are running on the road with velocity. At what angle you will see the rain? So I'll say simple thing. VR is velocity of rain. Okay. Let us take VM is velocity of man. Now man is observing the rain. Man is observing the rain. We need to find velocity of man with velocity of rain with respect to man is observing the rain. So velocity of rain with respect to the man simply. So the man will see this velocity. Man will see this. Simple. Man will see this. Now at whatever angle the rain is coming or with whatever speed the man is moving, you just find velocity of rain with respect to man. That is velocity of rain minus velocity of man, and that particular velocity the man will see. Now if he sees the rain to coming at 30 degree, he should bend his umbrella to 30 degree to protect himself. If he sees the rain is coming vertically, he should hold this umbrella vertically to protect himself. Getting it? So this is what he has to do. Now I'll explain this with help of some questions. Here you will understand how to do. When a car is at rest, the driver sees raindrops falling on it vertically. Car is at rest, he's seeing rain falling vertically. It means the actual velocity of the rain is vertical only. Yes, we got it. Okay, so the rain velocity is vertical. I got VR. Now when driving the car with speed V, he sees raindrops coming at an angle 60 degree with the horizontal. Now if he is driving the car with velocity v. So what he will see? He will see velocity of rain with respect to car. So velocity of rain minus velocity of car, minus velocity of car. Okay, this is VC I am writing. Okay, so what will be the angle? The resultant velocity will be along the resultant of these two vectors. So this basically becomes my velocity of rain with respect to car. And here the angle is discussed with the horizontal, this angle, or I can say it's the same as this angle. So if I ask you what is tan theta in this, you will say, sir, tan theta is perpendicular divided by the base. Getting it? This is my tan theta. Here is saying that angle is 60 degree. So I will say root 3 is initially, so this is v rain, and initially his velocity was v. Getting it? On further increasing the speed to 1 plus beta into v, the angle become 45 degree. Tan 45 is 1 v rain divided by 1 plus beta into v. Divide these two because you need to find beta. Divide these two. This v is getting cancelled. Vr is getting cancelled. From there you got 1 plus beta is root 3. Root 3 which is 1.73. So beta is 0.73. C option. Understood the concept? Rainman problems. Okay. So just see the velocity of rain with respect to man. That is the velocity the man is going to see. Now, shortest distance between two bodies. Sometimes some questions are like two particles are moving. One is moving in this direction, another is moving in this direction with this velocity. Okay. Now, what will be the minimum or the shortest distance between those two? How to find such things? So, these type of things also you have to do with relative velocity concepts only. Okay. Let us take example. Take an example of, let us draw some axis first. Okay. Generally, the question are asked like, here is A, here is B. Some velocities will be given. And then you need to find the minimum distance after this. So how to do? You observe the motion of other particle with respect to one of the particle. So what I will do? Let me observe how B is moving with respect to how A is moving with respect to B, or how B is moving with respect to A. Any of that you can do. Okay. Let me observe velocity of A with respect to B, and let us take it comes somewhat like this. This is velocity of A with respect to B. Now B is stationary. B with respect to B means I am sitting on B. Now when B is seeing it is moving in this direction, it means it will pass like this. If it passes like this, what will be the minimum distance? This will be my minimum distance. Perpendicular. The minimum distance of a point from a line is the perpendicular distance. So this perpendicular distance will be my minimum distance. Now you, whatever the things are given, you take the help of those things to find this d minimum. Okay. And if you find this d minimum, and let us take some, you have to find t minimum also. So you can find this distance also. L, let us take, and I can say that time minimum will be that particular distance divided by velocity of A with respect to B. Okay, so basic thing that I am telling you is that you have to observe the motion of the other particle with respect to one of the particle. I'll show you the question on this. This is the question. Okay, so here a ship is sailing towards northeast with velocity v 30 I cap plus 50 j cap kilometer per hour. I and j are along east and north. Okay, ship B is at a distance of 80 kilometer east, 150 kilometer north. Ship A is sailing towards west with 100 kilometer per hour, 10 kilometer per hour. A will be at minimum distance from B in. So he is asking in how much time A will be at minimum distance from B. Okay, let us show ships. Now ship A is sailing towards northeast with velocity. I am taking A here. Okay, let me take A here. Its velocity is given. How much? 30 I cap, 50 J cap. Ship B is at a distance of 80 km east and 50 km north. Somewhat here. This is 50. This is 80. And it is sailing towards west with 10 km per hour. Okay. Now, this is my A, this is B. I'll observe B with respect to A. So, I'm sitting on A now, observing B. Sitting on A, observing B. So, what is velocity of B with respect to A? That is velocity of B minus velocity of A. So, I'll subtract the velocity of A. Subtract means adding the vectors in opposite direction. 30 I cap is towards right. So, I'll give 30 I cap towards left. So, total will become 10 plus 30, 40. Okay. 50 I cap is towards upward, 50 J cap. Okay. So, it will be 50 like this with respect to B. Getting it? Now, the minimum distance I have to find. So, what is this here? This is the actual distance, initial distance between them. Okay. And this is 80, this is 30. How much is this angle? This angle is a 10. Let us take this as my theta. Okay. So, 10 theta I will say 80 by how much was that? The another distance was, I think, 150. Yeah, this was 150. I did a mistake here. This was 150. Okay. So, 80 by 150. That is 8 by 15. And this angle will be 4 by 5, which is greater than that. So, the resultant velocity will be somewhat in this direction. So, this B will actually pass like this. And the minimum distance will be somewhat here. I need time, the time, minimum time. This total angle with the vertical here is alpha, and I'll say 10 alpha is equals to, what is that? This angle, that is my 4 divided by 5. 4 by 5. Now, this initial distance is known to me. This distance between A and B, that is D. This initial distance, what is that? That is D is equals to root of 30 square plus 180 square plus 150 square. How much will be the minimum time? The time minimum when it reaches here. So that distance, what is this? This is D cos of alpha minus theta. D cos of alpha minus theta. This is the distance it has to cover. With what velocity it is moving? Root of 40 square plus 50 square. This becomes the minimum time. Okay, now here D we know, 10 alpha and 10 theta we know. So we can accordingly find 10 alpha minus theta. From there I can put cos alpha minus theta, and then we can solve it. And from here if we solve it, it will come out to be 2.6 nearly. This is certainly a bit lengthy question. Sometimes if these type of questions are coming, it's better to avoid for that time. Okay, solve other questions, come back, then do the calculations, because it will take a lot of time. But the key concept is same. You see the relative motion of other particle with respect to the one, and the minimum distance will be the perpendicular distance, and then the total distance, you know how much it has to travel, the velocity with which, you know, with which it will travel. You can find the time, that is the distance it will travel divided by the velocity with which it will travel. Now relative motion between two projectiles. Okay, so let us take two projectiles are there, maybe projected at some angle from any heights like this, theta 1 with velocity v1, v2, theta 2. Some things are asked when they will collide or if they are colliding or not, all these type of things are asked. So as I discussed previously, their relative velocities are not going to change. Why? A relative is equals to 0. A relative is equal to 0. V relative is constant. V relative will not change with time, and whatever the distance relative, you know, then you can find the time and other things you can find easily. Only thing is you should understand that A relative is 0. Both are having acceleration g in the downward direction. So A relative is 0. V relative will not change. So when you observe the motion of other particle with respect to one, he will say that it is moving with constant velocity. The velocity of the other particle is not changing, and writing the equations then become very easy. Although such questions are not asked in mains, for concept I was telling. Okay. Now we are moving to circular motion, and this is also a part where many times the question are asked, and they are very, I'll say, simple, easy. So let us understand the key concepts of circular motion. First of all, circular motion means particle moving in circle. You all know that. How we define the position? We define the angle. Okay. So let us take the particle is somewhat here at some angle. So we will say here angular position is theta. And angular position we define with respect to one reference line, and generally we take that reference line as my x-axis. So with positive x-axis we measure how much angle it has moved. Okay, that becomes my angular position. Okay, how much angle it moved till here, so this is the angle, so that becomes my angular position. Now if I ask you what is angular displacement, let us take it. Initially it was having angular position theta 1, finally it is having angular position theta 2. You will say the angular displacement or delta theta as final angular position minus initial angular position. Then comes the angular velocity. Now angular velocity means the velocity with respect to which the theta is changing. Like I say velocity, general velocity. You will say what is velocity? You will say rate of change of position. So if I ask you what is angular position, rate of change of angular position. So angular velocity we denote with omega. This is rate of change of angular velocity. Rate of change of angular velocity, or I can say omega, is d theta by dt. Is this a vector or scalar? It's a vector. Even our angular position is also a vector. How that is defined, this vector? Okay. So let us take the particle is moving like this. So here the angular position, angular velocity is out of the plane. Okay, we take this as out of the plane. So out of the plane, I'll say dot. This is the direction of my angular velocity, and if it is moving like this, so it is into the plane. Okay, we can like move our fingers in the direction of the motion like this. So the direction of thumb, right hand thumb rule. Okay, so the direction of the thumb, here it is into the plane. So this is the direction of my angular velocity. And sometimes we may need to find average angular velocity. So using the same concept, you can say that omega average is equals to change in the angular position divided by the time interval. Simple. Okay. Next, the angular acceleration. The way we defined acceleration, how? What was the acceleration? Rate of change of velocity. So what is angular acceleration? You will say rate of change of angular velocity. So angular acceleration alpha is rate of change of angular velocity. Simple. If alpha is positive, omega will be increasing. Okay. Isn't it? Yeah, like it depends. It depends in which direction it is. If they are both in the same direction, okay, they both are in the same direction, omega will be increasing. If they are in the opposite direction, omega will be decreasing. That is the concept basically. Okay. So how we define the direction of alpha? If omega is increasing, alpha is in the direction of omega. If omega is decreasing, alpha is in the direction opposite to that of omega. And similarly, if I write the average angular acceleration, you will say that is change in the angular velocity divided by the time interval. Coming to the concepts. Now, the way like we used to relate velocity, acceleration and position, the same way we will relate these things. If you have to find omega from here, you will say d omega is equals to alpha dt. So omega will be like integration of this. Okay, so delta omega will become integration of alpha dt. Okay, omega 2 minus omega 1. So all those concepts we will be using here also. Let us do this question. A ball is spun with angular velocity that is 6t square minus 2t, where t is in second and alpha is in radian per second. At t is equals to 0, the ball has angular velocity 10 radian per second and angular position 4 radian. The most appropriate expression for angular position of the ball is alpha is given. Matlab means the angular acceleration is given, we need to find the angular position. I'll integrate angular acceleration to find the angular velocity, then I'll integrate angular velocity to find the angular position, and from there I'll get my answer. Okay, so alpha, what is alpha? Alpha is d omega by dt. So d omega is basically 6t square minus 2t dt integrating both sides. Initial omega was 10, final omega, let us take that is omega, time goes from 0 to t. So if I integrate from here, omega will become 3, it will become 2t cube minus t square. Okay, t square by 2, so 2 is cancelling, I am writing like that, getting it, and then plus 10, because on the left side integration of omega, if I do from 10 to omega, okay, so the limit will come from 10 to omega, omega minus 10, so 10 will come on the other side, so plus 10. Everything is perfect? Yes. Now this omega I'll write as d theta by dt. So d theta will become integration of like I'll integrate it after. So d theta is basically 2t cube minus t square plus 10 into dt, integrating both sides. Theta changes from initial at t is equals to 0. What was theta? 4 radian. So 4 radian to some theta, okay, position, okay, time goes from 0 to t, again integrate it, so this will become 2 t to the power 4 by 4. So t to the power 4 by 2 minus t cube by 3 plus 10t, and here it will become theta minus 4, so theta will become this plus 4 plus 4, t to the power 4 by 2 minus t cube by 3 plus 10t plus 4, B option. Simple thing, nothing like complicated. Acceleration is given. If somebody asks you what is the position, you will 2 times integrate and give the answer. Similarly, here it is angular acceleration is given. You need to find the angular position, integrate 2 times and give the answer. Relation between linear and angular velocity. Like we need to, angular velocity is omega, linear velocity is v. How to relate that? Okay, let us take here the particle is here, okay. At this instant it is moving with angular velocity omega, at that instant, okay. So it would have covered some distance. Let us take this distance ds. Here this angle is d theta. It covered this distance ds, and I'll say that ds is equals to r into theta, r into d theta, because length of arc is equal to the angle subtended by the arc into the radius. That is clear. Differentiate it with respect to time. So by dt, what it will become? Ds by dt is what? The velocity there. Okay, ds by dt is the velocity there, linear velocity there, not angular, and this r into d theta by dt is my angular. So v is equals to r omega. This is the relation between the magnitude of the velocity and magnitude of the angular velocity. Now let us see the direction, which direction it will be. You see, particle is moving in circle, velocity is in this direction, omega is out of the plane. If you do omega cross r, that is the direction of velocity. So v is basically omega cross r. This we write in terms of the vectors, vector forms. Okay. V, when it is moving in circle, V and R are perpendicular only. The angle between that is perpendicular. Okay, omega cross R magnitude, we know omega R sine theta, sine 90 is 1. So V is equals to R omega. This is the relation between the magnitudes. Now, relation between linear and angular acceleration. So we know V that we got as R omega. Okay, if I differentiate this, so dV by dt, that will become R into d omega by dt. This is rate of change of speed. Okay, this is rate of change of speed. And what is this? This is alpha. This is my rate of change of speed. Now, why I am not writing rate of change of velocity here? Because the velocity is changing its direction also. There are two accelerations there. One is the one which is changing the magnitude of the velocity, another is that which is changing the direction of the velocity. The one changing the magnitude of the velocity is rate of change of speed. Okay, and this we call as the tangential acceleration. This we also call as the tangential acceleration. It changes the magnitude, not the direction. This is I'll say responsible to change the magnitude of the velocity. Change the magnitude of velocity. Getting it? This is responsible to change the magnitude only. Now, uniform circular motion means the speed remains constant. Speed is constant. Is the velocity constant or not? No, velocity is changing. Is the acceleration 0? No, velocity is changing means acceleration is there. So which acceleration it would be here? Tangential acceleration will not be there because the magnitude of speed is not changing. Only centripetal acceleration will be there. In this case, only centripetal acceleration will be there. Okay, let us take the particle was here, moving with some velocity v. It went here. Here velocity is v, covering some angle. Let us take this is theta, or I can say some small angle I can say. Okay, let us take d theta or theta. I am considering this to be small. It came there. So what is change in velocity? So this was initial velocity. This is my final velocity. The angle between the two is theta. Let me take d theta only so that you are not confused. So this angle is d theta. What is the change in velocity? This is final, this is initial. So final minus initial. Okay, I just want to find the magnitude, by the way. This is my final and this is my initial. So if I take the opposite of the two, opposite, okay, so this I'll just draw the opposite like this. So how much that angle will be? 180 minus theta. 180 minus d theta. This is v, this is V. What will be the resultant of the two? That will be along the bisector, I'll say. And how much that? 2V cos of half of this angle, 90 minus d theta by 2. So 2V sine d theta by 2. This is my delta V. And what is delta T? Delta T is the distance it covered, r d theta, by the speed with which it was moving, like this. Divide the two to find the accelerations. Delta V by delta T. What is that? That is sine d theta by 2, you can write as d theta by 2, okay? And d theta will get cancelled, it will become V square by r. What is the direction it is coming? Along the bisector. Along the bisector means towards center. So the centripetal acceleration, if the particle is here, it will be in this direction. If the particle is here, it will be in this direction. If the particle is here, it will be in this direction. When uniform circular motion is there, only centripetal acceleration is there. Tangential acceleration is 0 and centripetal acceleration is V square by r, and it is towards the center. Coming to questions. A stone tied to 180 centimeter long string at its end is making 28 revolutions in horizontal circle every minute. The magnitude of acceleration of stone is, now it is mentioned, it is making these many revolutions every minute. It means what? It is moving in uniform circular motion. Yes. Which acceleration will be there? Centripetal acceleration. What is the formula for centripetal acceleration? V square by r. And also you can write this as V as r omega. So it will become omega square r. How we can get omega from here? It is, omega is radian per second. How much radian per second it is covering? 28 revolutions per minute. How many revolution per second? 28 by 60. These many revolutions per second. How many radians per second? Into 2 pi. So this becomes my omega in radian per second. Getting it? These many revolutions per minute dividing by 60 got per second, multiply 2 pi, got radian per second. So this and pi is given as 22 by 7. So this will become 28 by 60 into 2 into 22 by 7 into 4 into 15, 44 by 15. Okay, A centripetal is V square by r, V square or omega square r, omega we got. So 44 by 15 square, omega square r. Okay, what is r? 180 centimeter. Okay, tied to, this is the length, so that becomes the radius. So 180 centimeter, it means 180 divided by 100, 9 by 5. And this will become 44 square divided by 15 into 15 into 9 by 5. 3 into 5 into 5, this is 44 square divided by 125. 44 square is 1936. Okay, so what is x now? X we got as 125. Now non-uniform circular motion. Uniform circular motion means speed becomes constant. Non-uniform circular means speed is not constant. Speed is changing. The particle is moving in the circle and the speed of the particle is changing. It may be increasing, may be decreasing. So if the particle is, let us take here, having some velocity v in this direction, one acceleration, centripetal acceleration will be there. In this direction, a centripetal. Another acceleration which is increasing or decreasing the magnitude of the speed, that is tangential acceleration, that is in the tangential direction. Okay, and that can be upward or can be downward. If it is in this direction, it is increasing speed. If it is in the downward direction, it will be decreasing speed. Okay, the resultant acceleration will be the resultant of the two. Let me change the color. The resultant acceleration will be the resultant of the two. So A net acceleration is the resultant of the tangential acceleration and the centripetal acceleration. Why I wrote like this? They are perpendicular always. Therefore, I wrote it like this. They are always perpendicular. Okay, getting it? So this is what happens in uniform circular motion. Now, let us take uniform circular motion, non-uniform circular motion is there, and the condition is alpha is equals to constant. If alpha is equals to constant, like the same way when we had acceleration is equals to constant, we were having three fundamental formulas, this, and this. V is equals to u plus at, s is equals to ut plus half at square, v square minus u square is equals to 2s, relating the displacement, acceleration and the velocities. Similarly, we can have the same formulas for angular world also. Here we are having final angular velocity is equals to initial angular velocity plus alpha into t. V is equals to u plus at. This is also v is equals to u plus at in angular terms. Final angular velocity is initial angular velocity plus alpha into t. This is only applied when alpha is constant. Remember it, not always. Similarly, I can write the angular displacement like this. Similarly, I can relate the final angular velocity and initial angular velocity like this. And these two derived formulas, if you want, you may remember. If you don't want, you may not. So you know that if a is constant, displacement is final velocity plus initial velocity by 2 into t. Same thing I can write here. Final angular velocity plus initial angular velocity by 2 into t. And similarly, the displacement in nth second, we know the formula. So this becomes the angular velocity in nth second. Sorry, angular displacement in nth second. Coming to questions. A body rotating with angular speed 1600 revolution per minute is uniformly accelerated to 1800 revolutions per minute in 10 seconds. The number of rotations made in the process is, what is given? Initial angular velocity is given 600 revolution per minute. Final angular velocity is given 1800 revolutions per minute. Time is given 10 seconds. Number of revolutions we have to find. We can find the angular displacement and accordingly we can find number of revolutions. So we know that S is equals to this, alpha is constant here. So S is equals to final minus initial divided by 2 into T. This not S, this is my delta theta, angular displacement. Getting it? So angular displacement here is, this is revolutions per minute. If I multiply the time in minutes, I'll get revolutions directly. Need not convert that to radian per second and then again divide with 2 pi to find the revolutions. No, this is in revolutions per minute. I'll put omega in revolution per minute, multiply the time in minutes to get the number of revolutions. So 1800 minus 600 by 2, multiply the time in minutes. This is in seconds, so 60 by 60, 10 by 60, so that will become in minutes. So what it is now here, this 10 is getting cancelled. So what it is, 1200 divided by 12. So this is 100 revolutions. Okay, so in this process, it made 100 revolutions. Another question, a flywheel is accelerated uniformly from rest and rotates through 5 radian in first second. The angle rotated by flywheel in the next second is, okay. So in the first second, if I write the angle at the displacement, okay, so it is starting from rest. So theta is equals to, we know S is equals to ut plus half at square. Starting from rest, u is 0, so omega naught is 0, so half alpha t square, so 1 square, and this is given as how much? 5. The angle rotated by wheel in the next second. So in the next second, how much it will rotate? So the angle it rotated till 2 seconds minus the angle it rotated in 1 second. Half alpha 2 square minus half alpha 1 square. Okay. So this is the angle it will rotate. So how much is this? So it is alpha into this is 2 minus 1 by 2, isn't it? 2 minus 1 by 2. What is that? 3 by 2. Everything is fine. 2 minus 1 by 2 is 3 by 2. Alpha is 10. Alpha is 10. So this is my theta dash, I'll say. Alpha is 10. From here I can say alpha is 10. So if I put alpha is 10, so this will become 15 radian. Option B. Okay. Let us see if we did any mistake. For 1 second first, theta is equal to half alpha t square, that is 5. For second we have to find what we did, total angular displacement in 2 seconds minus in the first second. So that will get for second. So half alpha into 2 square minus half alpha into 1. So this will become 2 minus 1 by 2, 3 by 2 alpha. Alpha from here is 10. So if you put 10, so this will become 15 radian. That is option B. Yeah. Okay. Now this question is based on relative velocity, and let us check it what he is asking here. This is a straightforward question asked in JEE Mains 2019. Two particles A and B are moving in two concentric circles of radii r1 and r2 with equal angular speed omega. Okay, both are having omega same. At t is equals to 0, their positions are directed. Positions and directions of the motion are shown. Okay. The relative velocity at pi by 2 omega. Now time is given as pi by 2 omega. Their angular velocity is omega. How much angle they will rotate? Omega is constant. So omega into pi by 2 omega. So that become pi by 2. So angle it will rotate is pi by 2. So it will rotate pi by 2. If A will rotate pi by 2, A will come here. If B will rotate pi by 2, B will come here. With what velocity A will move? R1 omega. With what velocity B will move? R2 omega. What is VA if I ask you? You will say, sir, VA is equals to, it is R1 omega minus I cap. So minus R1 omega I cap. VB, this is minus R2 omega I cap. What is VA minus VB? So VA minus VB, if you do, that will become R2 minus R1 into omega I cap. Everything is right? Yeah. See. So we did so many questions we took, so many varieties, like whatever things are asked in JEE Mains from whole of the kinematics, starting from 1D motion to 2D motion to the uniform circular, non-uniform circular motion. So whatever the possible varieties were there that were asked in JEE Mains, we took all of them. Okay, so this video is, I'll say, very important, and if you have skipped some part of this video, I'll say please go and watch it completely. This is very important. Actually, I have taken all the key concepts whatever is required for JEE Mains for kinematics. If you watch this video and if you have solved all these problems with me, I'll say for sure you are going to crack, I'll say, all the kinematics questions for JEE Mains. Okay, that will help you actually. And what else now? It's like you have understood all the concepts, you have solved questions with me. Now it is time for self practice. So after this video, just click on the link given in the description box. From there you'll go to the app. Okay, our app, there is our free batch. You'll join that free batch, and in that free batch you'll get the notes of this video as well as the DPPs. Now we have made practice sheets for you, and these practice sheets are, I'll say, very important for you to go through. We have selected questions in that. Okay, the different varieties that are asked, all those varieties, whatever type of questions we have covered in the class. So make sure after this class you'll go to that link and practice the questions. This is very important. Thank you all. We'll meet in the next video. Have a nice day.